Hello everyone, welcome to Payment Tech Media. In this video series, we will talk about IPv4 subnetting. So stay tuned, let's jump into my computer and take a look. So in previous videos, we talked about IP address, IPv4, we talked about different classes and their default subnet mask. Now let's talk about classless subnet mask. So what is this classless subnet mask? Or what is this IPv4 subnetting? What is the purpose of subnetting? As we previously talked about, that pretty much anytime when we want to manage and be able to better organize our devices on the network, we probably want to break a large network into the smaller network to better manage the devices on the network. Or sometimes we don't want to waste too many IP addresses. Let's say a company with only 20 employees, or let's say 20 computers, devices on the network, so doesn't need 254 IP addresses. So breaking large network into the smaller network, not to waste too many IP addresses. Or another reason could be because of security reasons. So let's say having specific subnet designed for human resource department, specific subnet designed for marketing department, and another subnet designed for finance department, sales department, and so on. So basically, be able to break a large network into the smaller network. So that's subnetting. So previously, for quick recap, as we talked about in IPv4, we have 5 different classes. Class A, B, C, D, and E, which we talked about mainly. Class D is for multicast purposes, and Class E is for scientific and research purposes. And mainly, we will have subnet mask for Class A, B, and C. So the default subnet mask for Class A, as you guys already know, is 255.0.0.0. And default subnet mask for Class B is 255.255.0.0. And the default subnet mask for Class C is 255.255.255.0. Which again, these subnet masks, these are decimal notation format. And here in IPv4, as you guys already know, we have 32 bits. And this is the binary format. And you can see all the 32 bits. So this is the first 8 bits, the second 8 bits, the third, and the fourth. This is also known as the first octet, second octet, the third octet, and the fourth octet. So here, this is the decimal representation of this octet. So this is the first octet, the second octet, the third, and the fourth. In the previous videos, we talked about how we can convert binary to decimal or decimal to binary. Please make sure to watch those videos. So here, this 255, it pretty much means here we had 8 ones. And anytime in any octet, all the bits turned on, we have to add all these decimal values to the top. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 and plus 1, which gives us 255. And previously we talked about that 1 means on and 0 means off. So 1 is network bits and zeros are host bits. For example, in Class A default subnet mask, we have 8 bits for network bits and we have 24 bits for host bits. So these are the default subnet mask. For Class A is the first octet for the network. Class B, the first 2 octets for the network, and Class C, the first 3 octets for the network. Therefore, it gives us only the last octet for the host. So we will have 8 zeros in Class C, the last octet, 8 bits for host, and 24 bits for network. In Class B, 16 bits for network and 16 bits for the host. Again, these are the octets, decimal representation of these binary numbers. So if this is 255, 8 bits here, the second octet 255, 8 bits here, the third octet 0, so 8 bits 0 here, and the last octet 0, 8 bits 0 here. But of course this one is for class A. For class B, it would be, let's erase all this, and let's add all this as well. So this is an example of class B default subnet mask, 255.255.0.0. And for class C, let's erase all this and add. So we have 24 bits for network and 8 bits for host. That's a total of 32 bits. Again, in IPv4, we have 32 bits. So previously we talked about the number of hosts. So number of hosts is 2 to the power of host bits minus 2. Which when we talk about, let's say, class C, how many host bits do we have? Only the last octet is for the host. So in the last octet, 8 bits of zeros. Here we can see 8 bits of zeros. This is for class C, default subnet mask. So 2 to the power of 8 minus 2. 2 to the power of 8 is 256 minus 2, which is 254. Therefore, default subnet mask class C, every network we will have 254 available IP addresses. That's why we do the minus 2, because one IP address for network address and one IP address for the broadcast address, and all the available IP addresses in between, that's the available usable IP addresses that we can use. Again, in previous videos we talked about a lot more in detail when we went over the default subnet mask for each class. So always this address will be the network address, and this address will be the broadcast address, and all the available IP addresses in between, these are the usable IP addresses we can assign. So when we do the minus 2, we are basically reserving one IP address for network and one IP address for broadcast address, and the result is pretty much all the available IP addresses that we can use and assign to the computers on the network, to the interfaces, devices on the network, and so on. So this class C default subnet mask gives us 254 available IP addresses, right? It's pretty much like a big box with 254 available IP addresses. Now let's say we want to break this big box into the smaller boxes. So let's say into the 4 smaller boxes. That's an example of subnetting, breaking a large network into the smaller network. And how can we do that? By borrowing from the host bits. Which, speaking about borrowing from host bits, it's pretty much when we have our network bits, and this is the host bits, the zeros, it's pretty much taking away from the host bits and borrowing into the network bits. So all these ones, these are the network bits, network bits, network bits. Here we borrowed from the host bits. This will be our subnet bits. And the zeros, it's our host bits. So in this case, we have 24 network bits, and that's the default subnet mask for class C. We borrowed 3 bits to be part of the network bits. We turned on these 3 bits from the host bits, and it goes from left to right. So here, 1, 2, 3. 3 bits we borrowed. This is just one example. And here we have 5 zeros, 5 host bits. So now our cut line, it's not here anymore. Originally it was here, but now it is here. So what would be the CIDR notation? We have to count the number of ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and up to here, 24, 25, 26, 27. So that will be our CIDR notation. /27, classless interdomain routing, known as our CIDR notation. So if we want to convert all this binary into decimal to write down our subnet mask, would be our new subnet mask is 255.255.255 How many bits here? Borrowed 3. So basically, this is an example of converting binary to decimal. Again, previously we talked about how we can convert binary to decimal. Make sure you watch those videos. So here we have only these 3 bits turned on, so we have to add the decimal values for these 3 bits. 128 plus 64, that's 192, plus 32, that's 224. So this is our new subnet mask. Is this default subnet mask? No, because default subnet mask for class C is 255.255.255.0. But this one is 255.255.255.224. What does it mean? Means that we did borrow 3 bits on the last octet, because here we can see the 224. So remember, every octet that we have all the 8 bits turned on, that's 255. This is the first octet, all the bits turned on. Here the first octet, 255. The second octet, all the bits turned on, second octet, 255. And so on. The third octet, 255. And here we can see on the last octet we have only 3 bits turned on, so that gives us 224. Now if we apply the same formula that we talked about, the number of hosts, 2 to the power of host bits minus 2, right? So originally we had, for class C default subnet mask, we had the last octet all zeros, right? So we had 8 bits of zeros, 2 to the power of 8 minus 2, and it gave us 256 minus 2, 254. But what about now? Let's see. By borrowing these 3 bits, therefore we will have only 1, 2, 3, 4, 5 bits left for the host bits. So let's erase all this. So we have 2 to the power of host bits. How many host bits do we have now? Zeros represent the host bits, ones represent the network bits, right? So the zeros representing the host bits, we have only 1, 2, 3, 4, 5. 2 to the power of 5 minus 2. Again, minus 2 because of the network address and the broadcast address. So we do the minus 2 to get a usable IP addresses, number of hosts that we can assign to the computers. So 2 to the power of 5, that's 32, minus 2, that's 30. So we will have 30 available IP addresses per subnet. So this section, again, you guys already know the default subnet mask for class A, for class B, and for class C, right? I'm gonna go ahead and erase all this to make some space. Okay, so this is just one example of subnetting. We did break large network, let's say default subnet mask class C, into the smaller network, and we borrowed 3 bits just as an example. And then we did find out our new subnet mask and then the CIDR notation. Just remember, this CIDR notation and the subnet mask is pretty much the same. This is the full version writing down the subnet mask, and this is just a short version of the subnet mask writing the CIDR notation. The /27 means 27 being turned on. The number of ones turned on, number of zeros turned off. Ones, network bits, zeros, host bits. And applying the same formula, now we did find out that we will have 30 available computers per subnet. You see, now we are saying per subnet. So originally, the default subnet mask for class C, we will have 254 available IP addresses per class C network. But now, with this CIDR notation, this subnet mask, we will have 30 available IP addresses per subnet. We do have also a formula to find out how many subnets we will have. Let me erase this. So to find the number of subnets, 2 to the power of subnet bits. So in this case, how many subnet bits we have? 1, 2, 3. So we borrowed 3 bits from the host, all the host bits, right? So these are our subnet bits. So it is 2 to the power of 3, which is 8. So it gives us 8 subnets. And each subnet, we will have 30 available IP addresses per subnet. So in other words, let's erase this. Originally, we had a default subnet mask class C, 255.255.255.0, that gave us 254 available IP addresses per network, right? If we had this big box with 254. And but right now, using this CIDR notation, 27, now this is subnetting. So breaking down this big box into the 8 smaller boxes. So now after subnetting our big box, it's pretty much divided into 8 smaller boxes. So let's draw 8. 1, 2, 3, 4, 5, 6, 7, 8. So here 8 smaller boxes inside this one big box. So originally default subnet mask class C, we had one network with 254 available IP addresses per network, right? So after subnetting, in this example, we just borrowed 3 more bits from the host bits, right? So that's a total of 27 now, 27 bits for the network, and only 5 bits for the host, which we talked about. The number of hosts, 2 to the power of host bits minus 2, because of network address and a broadcast address we cannot assign to the computers on the network, so we have to do minus 2, 1 for network address and 1 for broadcast address. So that gives us the number of hosts. 2 to the power of host bits. Here we have 1, 2, 3, 4, 5. So 2 to the power of 5 minus 2, which is 2, 4, 8, 16, 32. 32 minus 2, so that's 30. So basically, in other words, we have 30 available IP addresses per subnet. So let's write 30 here. So this is an example of subnetting class C network. Originally one big box with 254 available IP addresses, broken down into the 8 smaller boxes. Now each we have 30 available IP addresses per subnet. And this is just because of this subnet mask. Now it depends if we had different subnet mask, different CIDR notation, different cut line. So it would give us different number of subnet bits and different number of host bits. Based on that, we could find out how many subnets we have and how many available IP addresses we have per subnet. Now let's see this in action. So I'm going to go ahead and erase all this. So let's say they gave us IP address, class C IP address 192.168.1. Let's say 82. And of course the CIDR notation is, this is 8 plus 8, 16 plus 8, 24, 25, 26, 27. So the CIDR notation 27. And we already know this CIDR notation 27 gives us 255.255.255.224. Where this 224 is coming from, here on the last octet we can see 1, 2, 3 bits turned on. So this, here we can see 128 plus 64 plus 32. That gives us 224. Basically once we just need to add, when we convert binary to decimal, we just need to add the decimal values of the bit positions that it's being turned on. In this case, this one turned on, this one turned on, this one turned on. So 128 plus 64 plus 32 gives us 224. And again, why here 3 bits? This is just one example to show you guys subnetting, but we will in the future talk about based on the number of hosts, where we need to draw a cut line, all that. Okay, so having this IP address and the CIDR notation 27, they said this IP address, find out this IP address belongs to what network. So in the previous videos we talked about the ANDing formula, and same applies here. If we convert this IP address into the binary and convert this subnet mask into the binary and applying the ANDing formula, and the result, when we convert the result to decimal, that decimal is our network address. Okay, so we have to start from the 0 network. This is class C, default class C. Subnet mask is 255.255.255.0. So let's write down 192.168.1.0. That's the 0 network. How do we know? Because again, 192, the first octet, falls into class C, and the default subnet mask 255.255.255.0 for the default subnet mask class C. Therefore, the last octet is the host bit. So for the host bit, we just put 0. And here we can see this is our network address. Let's open parentheses to see our range. And then here will be our broadcast address, which we talked about previously. The easiest way to find the broadcast address is to find the next network first. And then one IP address less than next network is our broadcast address. So how can we find out the next network? It's basically by the use of network increment or block ID. So the last bit that is turned on, the decimal value of the last bit that is turned on, that's our network increment. In this case, what is the last bit that is turned on? Again, left to right. If we continue all the bits turned on, this is the last bit that is turned on. So what is the decimal value for the last bit that is turned on? 32. This is our network increment. So we are incrementing by 32. On what octet? On the last octet. Because we are working on the last octet. The cut line is on the last octet. So the next subnet, you see, I said the next subnet, not the next network. If we follow by the default subnet mask, that would be the next network. But because we are using subnetted bits, so it's known as next subnet, which is another network basically. So breaking large network into the smaller network or subnetworks. Okay, so the next subnet would be 192.168.1.32. Why 32? Because again, the last bit that is turned on here, this is the cut line, after that is 0, right? So this is the last bit turned on. The decimal value, 32, that's our network increment on the last octet. So on the last octet here, we put 32. And remember, these are the network addresses in this column. And here in this column, our broadcast addresses. Okay, if I want to continue, moving on to the next subnet would be 192.168.1.64. If I want to continue incrementing by 32, keep incrementing by 32 because of the network block ID or network increment ID. Okay, that's fine, that's enough. We should be able to easily write down our broadcast address, which again, the broadcast address is one less than the next network or the next subnetwork. In this case, this is our first and this is our next network. So the broadcast address for the first network would be one less than this, which is 192.168.1.31. If we add one IP address, it would be 32. Okay, so that's our broadcast address here. Now let's go over the ranges. Available IP addresses. So the first available IP address in this network would be 192.168.1.1. That's the first available IP address, and it goes to 192.168.1.30. And here you see this is one subnet, or one, as I mentioned earlier here. So, and each subnet we can have 30 available IP addresses, and here as we can see 1.1 to 1.30, that's 30 available IP addresses. If we count 1.1, 1.2, 1.3, I'm just kidding, but it should be 30 available IP addresses as we can see here. If we want to move on to the next subnet, the broadcast, one less than the next subnet here. So for this subnet, let's say this is subnet 1, subnet 2, subnet 3, and here for subnet 2, we have the broadcast address is one less than the next subnet, which is subnet 3, 1.64. So this one should be 1.63. Again, 192.168.1.63, because the next one is 1.64. And the available IP addresses, the range now goes in between basically 1.32 to 1.63. So that would be 192.168.1.33, and it goes to 192.168.1.62. 2. So these are the available IP addresses in this subnet. So let's say if this is our other subnet, for example, and we have 30 available IP addresses in that subnet as well. Again, here we can see 1.33, 1.34, 1.35 to 1.62. That should be 30 available IP addresses. So again, remember, with the Saturn notation of 27, subnet mask of 255.255.255.224, we can have 8 subnets. We can have 30 available IP addresses per subnet. So far, you guys saw this 30 available IP addresses per subnet. But let's go ahead and take a look. Where is this 8 subnets? Okay, do you remember the last bit we talked about? That's our network increment. We have to keep incrementing by 32. So if we keep incrementing by 32, you will see we will have up to 8 available subnets. After that, it goes to the next network, which I'll show you guys right now. So let's continue incrementing by 32. So 64 plus 32, that's 96. 96 plus 32, that's 128. 128 plus 32, that's 160. 160 plus 32, that's 192. 192 plus 32, that's 224. And 224 plus 32, that's 256. I'm going to write down here dot 256, and I used different color because in IP address, IP version 4, we don't have 256 in an octet, because every octet the range goes from 0 to 255. Why? Because every octet we have 8 bits. That's actually the name coming from octet, octal, octagon, right? So we have 8 bits, number 8. So if all the 8 bits turned off, that's 0. If all the 8 bits turned on, that's 255. So if we continue incrementing by 32, right? So here earlier we talked about our network increments. So after, when we get to 224 plus 32, that's 256. So what happens here, it will be 192.168.1.256, right? And again, we don't have 256, so it will turn to 0 and add to the next octet to the left, which is 192.168.2.0. And here 2, we are on the 1.0 network. So if we go to 2, we will be on different network. Therefore, here we can see the Saturn notation of 27, or the subnet mask of 255.255.255.224 will give us 8 subnets. This is the first subnet, second, third, the fourth, fifth, sixth, seventh, and the 8th subnet. After that, the 9th subnet, that's 256, which we talked about, that's not correct. It will take us to the next network. So when we talk about the subnets in the 1.0 network, it's total of 8 subnets, including the 0 network here. So here we can see, by just borrowing 3 bits here on the default subnet mask for class C, gives us a Saturn notation of 27. The subnet mask of this value, we can have, instead of one big network with 254 available IP addresses, instead of that, we can have 8 different subnetworks, and each subnetworks we can have 30 available IP addresses per subnet. Okay, so this IP address now falls into which subnet? What do you guys think? So let's erase all this. And here we can see 82 on the host bits, right? 82. So 82, and here we can see the increments. So 82 falls into which one? It's not between 96 and 128. It's between 64 and 96, correct? So it is in this subnet, in the 1.64 subnet. And the broadcast for the third subnet is one less than the next subnet. 96 is the next subnet, so it is 192.168.1.95. So 1.95 is the broadcast address for this subnet, and this IP address 1.82 falls into the 1.64 network. So the first available IP address in this subnet is 192.168.1.65, and it goes to 192.168.1.1 less than the broadcast 94. If we add one IP address, 95, that's the broadcast. If we add one IP address, 96, that's the next subnet. Why? Because of this subnet mask 255.255.255.224, which it gives us the cut line here, this 224. On the last octet, if we convert 224 to the binary, that's 111000000. So we know between 1s and 0, if we draw a cut line, the last bit that is turned on, 32, our network increment. So in other words, this IP address falls into this subnet. And the network address for this IP address with this subnet mask would be 192.168.1.64. And again, if we convert this to the binary, and apply both of them the ANDing formula, when we get the result, the binary result converting to the decimal, we will get 192.168.1.64. But this is another way to find out the network address for this IP address with this subnet mask. And therefore, let's say if this is the third subnet, and here 1, 2, 3, so this IP address would be on this subnet. So between 1.65 to 1.94, 1.82, it's between in this range. And the broadcast address here, if a router receives a packet with the IP header destination address of 192.168.1.95 with the subnet mask of 255.255.255.224, the router will forward the packet to all these IP addresses here in this range. So this will be the broadcast address for this network address with the subnet mask of this. And again, this IP address falls into this range in this subnet. Let's say they gave us the network address of 192.168.1.0 network and default subnet mask, the SADA notation 24 for class C, 192, that's class C network. So the default subnet mask, very good, 255.255.255.0. But the question they're asking that we don't want to use default subnet mask because it will give us up to 254 available IP addresses, but we don't want to waste too many IP addresses. So they said we only need 20 IP addresses. So they only need 20 IP addresses, they don't want 254. So we need to do subnetting, breaking a large network into the smaller network. Okay, so the default subnet mask here, class C, 255.255.255.0 means the first octet, it's all turned on for the network bits. The second octet also turned on for the network bits. And again, 1s represents the network bits, 0s represents the host bits, and 1 means on, 0 means off in the binary number system. Okay, so here on a third octet, 255 also means 8 bits turned on, because again, anytime when we have in the binary all the 8 bits turned on, here the decimal values 128 plus 64 plus 32, because all of them turned on, it will give us 255. And the last octet, it's pretty much all turned off. Okay, so they are asking for 20 hosts or 20 available IP addresses. So earlier we talked about the number of hosts, 2 to the power of host bits minus 2 to get the available IP addresses, right? Number of hosts. We take out the network address and the broadcast address, so that's why we do the minus 2. And number of subnets, 2 to the power of subnet bits gives us the number of subnets. So they said 20 hosts. One way to find out, we can just simply count at the bottom, going from right to left, starting with number 2. So 2, 4, 8, 16, 32, and again it's by block, so block size, 2, 4, 8, 16, 32. Here, minus 2, it gives us 30. Very good, they're asking for 20 hosts, so here it's perfect. We can just stop here for the number of host bits, for the number of zeros. Because if we stop here at 16, it's not enough. We need 20. So let's draw a cut line here. And we need to borrow from these host bits. So these are turned on. And this is our cut line. These are turned off. Yes, they did ask for the 20 hosts. And the closest block that meets our requirements is this one. If we apply the formula, so here how many host bits do we have? 1, 2, 3, 4, 5, right? So 2 to the power of host bits minus 2. So 2 to the power of how many host bits? 5 minus 2. So that's 32 minus 2, and that's 30. How many subnets? 2 to the power of subnet bits. How many subnet bits we have? 1, 2, 3. So 2 to the power of 3, which is pretty much kind of same formula applies if we count going from left to right, starting with 2, 4, 8. So left to right, starting with number 2, that's for the number of subnets, and going right to left, starting with number 2, and then at the end minus 2, that's number of hosts. This is also another way to find out. So let's apply this formula. We said 3 subnet bits, 2 to the power of 3 equals, so that gives us 8. 2 times 2 times 2, right? So 2 times 2, that's 4, and then 4 times 2, that's 8. So that's 8 subnets. So this network address with the default subnet mask, if we need 20 hosts per subnet, what is our new subnet mask? So our new subnet mask, it's not 255.255.255.0 anymore. So what is our new subnet mask? Well, we have to count all the number of ones, right? And then converting these binaries to decimal. So let's convert how many we have here, 8 ones. So in this octet, all the bits turned on. We just need to add these decimal values. So here we have 255. And the second octet also all turned on, so that's 255. The third octet all turned on, that's 255. And the fourth octet, we have the binary value 111000000. So we just need to add the ones that is turned on. In this case, 128 turned on, 64 and 32. So 128 plus 64, that's 192, plus 32, that's 224. So this is our new subnet mask, and the SADA notation would be, well, 8 plus 8, 16, plus 8, 24, 25, 26, 27. We are counting the ones, right? Network bits. So it is SADA notation of //27. 27. So anytime when we have this network address of 192.168.1.0 with the standard notation of 27 or the subnet mask of 255.255.255.224, it will give us 30 available IP addresses per subnet. And we will have up to 8 subnets. Each subnet, 30 available IP addresses. Let's see it in action. So let's erase all this. So it is 27 now, which is 255, 255, 255, 224, and they said 20 hosts. But of course, we will go by block, right? And this block is the closest one that meets our requirements and not wasting too many IP addresses, which gives us a 30. So this is our network address, the first 0 network, 192.168.1.0. What is the next subnet? What will be the increment? You guys remember earlier we talked about the last bit that is turned on. In this case, this is the last bit after we did the subnetting. So this is the last bit turned on. The decimal value is 32. So 32 is our network increment. So we are incrementing by 32 on the last octet. So next subnet would be 192.168.1.32. The next subnet would be 192.168.1.64. Next one would be 192.168.1.64 plus 32, 96. And if we continue incrementing by 32, right? So 192.168.1.128. 128 plus 32 is 160. So 192.168.1.160. 160 plus 32, 192. So 192.168.1.192. 192 plus 32, 192.168.1.192 plus 32, it is 224. And 224 plus 32 is 256. So 192.168.1.256. And I did use a different color. So of course we don't have 256 in the octet. So here we can see this is our first subnet, second, third, fourth, fifth, sixth, seventh, and 8 here. So this 256, it's not valid. Therefore, this standard notation of 27 will give us 8 different subnets, which applying the formula here we saw the number of subnets going from left to right, starting with 248 number of subnets. And the number of hosts going from right to left, starting with number of 248, 1632 minus 2 because of the network address and a broadcast address to get the available number of IP addresses. So every subnet we will have 30 IP addresses. Let's find out. So if this is our range and this column is the network addresses and this column here is the broadcast addresses. So for the first subnet, the broadcast address is one less than the next one. So the next one is 1.32. Therefore, the broadcast address would be 192.168.1.31. And here, if we go through the range, 192.168.1, 192.168.1.1, and it goes to, this is the first available IP address in this subnet, and it goes to one less than broadcast. So 192.168.1.30. So here we can see 1.1 to 1.30. That's 30 available IP addresses here, as we can see. So every subnet gives us 30 available IP addresses. The next subnet, 192.168.1.32, correct? Incrementing by 32, the last bit turned on. So this one, what will be the broadcast address for this subnetwork? So the broadcast address is always one less than the next subnetwork or the next network. So then in this case, next subnetwork is 64. So it would be 192.168.1.63. So for this subnet, 192.168.1.32, the broadcast address is 192.168.1.63. And the range is, the available IP addresses in that subnet is 192.168.1.32, that's a network. The next available, 33. So here we can see in this subnet, 192.168.1.32, the first available IP address, 192.168.1.33, and it goes to 192.168.1.1 less than the broadcast, 62. Because the broadcast address is 192.168.1.63, one less than the next subnet, right? So that's a broadcast address, that's a network address, and these are the available IP addresses for this subnet. And here we can see also we should have 30 available IP addresses. So 1.33 to 1.62, that's a total of 30 available IP addresses. And same thing applies for the next subnet. We should have 30 available IP addresses. And again, the broadcast address, one less than the next one. So what will be the broadcast address for this subnet? If the next subnet is 192.168.1.96, so one less is 1.95, right? So that's a broadcast address for this subnet. So 192.168.1.95. And the available IP addresses in between. So the first available IP address is 192.168.1.65, and it goes to 192.168.1.1 less than the broadcast, 94. And again, 1.65 to 1.94, that's a total of 30 available IP addresses. So the 0 bits, that's the host bits, 1s, that's the network bits. And here we borrowed 3 bits, so that these are our subnet bits. And we talked about the number of subnets left to right. 2, 4, 8 gives us 8 subnets. Each subnet we can have 30 available IP addresses. The number of IP addresses we can count going from right to left, 2, 4, 8, 16, 32, and minus 2 because of the network address and the broadcast address. So we have 30 available IP addresses per subnet. Now in this example, let's say they gave us another class C network address, but this time asking for different number of available IP addresses. For example, the network address, let's say 192.168.1.0 and default subnet mask 24. So it's a 255, that's class C, right? So default subnet mask for class C, 255.255.255.0, and they said we need 90 available IP addresses. So number of hosts, let's say 90. So previously we talked about counting right to left, starting with 2 at the bottom. We can count the number of hosts, 2, 4, 8, 16, 32, 64. Can we stop here? No, they're asking for 90 hosts. So 64, if we again continue doubling, right? 128. That's it. So this is perfect. 128 minus 2, 126. So 126 meets our requirements. They're asking for 90 hosts. We're not wasting too many IP addresses. 126, that's perfect. So we just need to borrow 1 block, right? So originally the default subnet mask, our cut line is here. So we have all the 24 bits turned on and the last 8 bits turned off. But asking for 90 hosts, when we do the subnetting, you see this is the original cut line, the default subnet mask for class C. We moved it to the right. That's known as subnetting. We will talk about supernetting, where we move the cut line to the left. That's supernetting. So subnetting, it's basically moving the cut line to the right, basically borrowing from the host bit and turning it on to be part of the network bits. So this is known as the subnet bits. These are the network bits, subnet bits, and of course zeros, host bits. Okay, so what is our new subnet mask and the CIDR notation? The CIDR notation, it's not 24 anymore, and the subnet mask, it's not 255.255.255.0 anymore. So the CIDR notation is 24 plus 1, right? So it's 25. And the subnet mask is 255.255.255, 1 bit borrowed, right? So it's 128. 128. So how many subnets do we have? The number of subnets going from left to right, right? Starting with 2. So it's only basically 2 subnets. Or we talked about this formula, the number of subnets, it's basically 2 to the power of subnet bits. And the number of hosts, 2 to the power of host bits minus 2, which again minus 2 because of the network address and a broadcast address. So that's what we see here, minus 2. Or in other words, if we count going from right to left, starting with 2, 2, 4, 8, 16, 32, 64, 128 minus 2, 126. These are the number of hosts. And number of subnets, it's only 1 bit here we have. So going from left to right, starting with 2. So 2, that's only 1 subnet. So that's basically gives us 2 subnets. And every subnet, we will have 126 available IP addresses. Let's find out. So if we apply this formula, 2 to the power of subnet bits, how many subnet bits do we have? 1. 2 to the power of 1, it's 2. And 2 to the power of host bits, all the zeros is host bits. So we have 1, 2, 3, 4, 5, 6, 7. 7 host bits. 2 to the power of 7 minus 2. So it should be 128 minus 2, which gives us 126. So we will have 2 subnets with each 126 available IP addresses per subnet. And if we see it in action, so we have 192.168.1.0, that's our 0 network, 192.168.1.0 network. And this is the network address, here the broadcast address. Now what is the last bit that is turned on? This is the last bit turned on. What is the decimal value? 128, that's our network increment. So we are incrementing by 128 on the last octet. So here we have 192.168.1.128. If we continue incrementing by 128, we will have 192.168.1.256. And again, I used different color. 256 not valid. So these are our 2 subnets. For the first subnet, what is the broadcast? Always broadcast is 1 less IP address than the next subnet. So if the next subnet is 1.128, 1 less IP address would be 1.127. So the broadcast address for this subnet would be 192.168.1.127. And the range, the first available IP address, 192.168.1.1, and it goes to 192.168.1.126. So 1 to 126, and here we can see 126 available IP addresses per subnet. How many subnets? 2 subnets we see. This is subnet number 1, subnet number 2. And here, of course, not valid, because if we continue incrementing by 128, we get 256, 256 not valid. In other words, it would be 192.168.2.0, because 256, it will be turned to 0 and add to the next octet to the left. So it will be 2, and that's a different network. We are on 1 network. Therefore, the standard notation of 25 gives us 2 subnets. Increment would be 128. And each subnet we will have 126 available IP addresses. They did ask for 90 available IP addresses per subnet or per network, but of course the closest block is this one, which we are not wasting too many IP addresses, and we're still meeting the requirements, the minimum requirements. For the next subnet, the broadcast here would be 192.168.1.255. That's the last IP address, right? If we add 1 IP address, it will be 256. We don't have 256. So it will be 0, adding to this one, 2, 192.168.2.0, right? So which we see here. So that's the broadcast for this subnet. And the first usable is 192.168.1.129, because 128 is network address. So 1 IP address to this network address, that's the first available IP address, which is 129. And it goes to 192.168.1.254, 254, one less IP address than our broadcast. So 1.129 to 1.254, that's a total of 126 IP addresses. Therefore, again, with the standard notation of 25, we will have 255.255.255.128 subnet mask. That's a classless subnet mask. It's not a default subnet mask. We will have two subnets, and each subnet we can have a total of 126 available IP addresses per subnet. So this time they gave us IP address, and they said this IP address belongs to what network. So the IP address they gave us 192.168.5.118 with the standard notation of 26. And they said this IP address belongs to what network. So the first step, by just looking at the IP address, this is class C IP address. How do we know? Looking at the first octet, 192 falls into class C range. So class C, this is 192, and the default subnet mask for class C is 255.255.255.0. That's a default subnet mask. But here, 26, we know that's not a default subnet mask, because when we have 255.255.255.0, that means we have 24 ones, not 26 ones. Let me show you. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 16. 1, 2, 3, 4, 5, 6, 7, 8. That's 24. That's a default subnet mask. So this is a default subnet mask for class C, but this is 26. It means we have 24, 25, 26. So basically these two added. So our original code line, default subnet mask for class C, it's here 255.255.255.0, right? Converting this binary to decimal gives us 255.255.255.0. But with the 26, when we count left to right, 26 ones, these are representing the network bits, and zeros representing the host bits. So if we draw a line between all the ones and zeros, so here is our cut line for our subnet. Therefore, all these ones, that's network bits, network bits, network bits, so our subnet bits, and these zeros, our host bits. So again, what was the first step? Simply looking at the IP address, the first octet 192, and then determining what class this is. This is class C. And then looking at this standard notation of the subnet mask. In this case, 26. It means 26 bits turned on. So here if we count, going from left to right, 8 plus 8, 16 plus 8, 24, 25, 26. So again, yes, the default subnet mask, the cut line was here. And as you can see, now the cut line moved here 2 bits to the right. This is known as subnetting. So anytime the cut line moves to the right, it's subnetting, breaking a large network into the smaller network. So we will have multiple other subnets, and each subnet has less number of hosts. Okay, and then here the zeros, it's pretty much for the host bits. Then what is the next step? Next step, we have to look at the last bit that is turned on. In this case, this is the last bit turned on. What is the decimal value for the last bit? So the decimal value for the last bit is 64. This is known as network increment or block ID. On what octet? On the last octet. So our network address is incrementing by 64 on the last octet. Okay, let me show you how. Well, you guys remember earlier I talked about this is class C, looking at the first octet. So we have to write down the zero network. So what is the zero network for the class C? Basically, we just need to write the entire network portion. And for the host portion, we have to put 0. Okay, so the network portion would be 192.168.5.0. This is the host portion, and that's the network portion. Because 192 class C, and class C is 255.255.255.0, right? Therefore, we can see here is the network portion, and to this side is the host information. Okay, now what would be the next subnet? Well, we have to increment by 64. The last bit turned on, decimal value, that's our network increment, right? On the last octet here. As we can see, we are working on the last octet, right? So the last octet is this one. Let's increment by 64 on the last octet. 192.168.5.64. And the next one, 192.168.5.64 plus 64, 128. And if we continue incrementing, 192.168.5, 128 plus 64, 192. And if we continue incrementing, 192.168.5.192 plus 64 is 256. So here, as you can see, I'm writing with different color, 256 not valid IP address. So here we can see we have 4 different subnets. And earlier we talked about the number of subnets. It's pretty much 2 to the power of subnet bits. And in this case, we have 2 subnet bits, 2 to the power of 2, which is 4. Or we can count at the bottom going from left to right, starting with number 2, 2, 4. So that's how many subnets we can have. And the number of hosts, we can count right to left, starting with 2, 4, 8, 16, 32, 64, minus 2, 62. So we will have 62 available IP addresses per subnet. We will have 4 subnets, each subnet 62 available IP addresses. Let's talk about this formula. The number of hosts, we have 2 to the power of host minus 2. So 2, how many host bits? 1, 2, 3, 4, 5, 6 host bits. So 2 to the power of host bits minus 2. And we have 6 host bits. Zeros representing the host bits. 2 to the power of 6 minus 2, which is 64 minus 2, and it is 62. So again, we can use this method going from left to right, starting with number 2 at the bottom to 4, and this is the number of subnets. And then from here, going from right to left for the number of hosts, starting with 2, 2, 4, 8, 16, 32, 64, and always minus 2 to get the available IP addresses. So we get 62. And again, we do the minus 2 because of the network address and the broadcast address. We cannot use them to assign to the computers or network devices. They are reserved, basically, reserved for the network address and the broadcast address, which is used by routers, routing protocols, applications, all that. So here we will have, again, 4 subnets, each subnet with 62 available IP addresses when we talk about the CIDR notation of 26. And what is this CIDR notation 26? If you want to write down in subnet mask, the full subnet mask version. So it is basically the first octet, all bits turned on. So that's 8 bits. In the first octet, that's 255. The second bit, all the 8 bits turned on. That's another 255. The third bit, all the bits turned on. That's another 255. And on the last octet here, we can see only 2 bits turned on, right? So when we count 26, so 1, 2, 3, 4, 5, 6, 7, 8, 16, 24, 25, 26. So on the last octet, we have only 2 bits turned on. So if we convert this binary to decimal, which again, my previous videos, make sure you watch if you haven't watched. I talked about how we can convert binary to decimal to binary, all that, number system conversions. So here we have only 2 bits turned on. And what is the decimal value? 128, 64. So we just need to add the decimal values of the ones that are already being turned on. In this case, this one turned on, this one turned on. The rest of them turned off. So 128 plus 64, that's 192. So this is our new subnet mask for the CIDR notation of 26. Okay, now let's take a look and see this IP address with this subnet mask or this CIDR notation falls into which subnetwork. So these are the 4 subnetwork. And let's erase to make some space. So we talked about that's not the valid one. So what we need to do, we have to look at the host portion. In this case, 118, that's for the host. And 192.168.5, that's for the network. So looking at 118, the last octet, And you see we were incrementing on the last octet, right? So we have to pay attention here for the last octet and then see this IP address, this number falls into which one. So this subnet 0 and the next one is 64. So 118, it's not in this one. 64 to 128. So 118 falls in between 64 and 128. Therefore, it is in this one. So let's write down the broadcast. If this is the network address here, the broadcast address for this network address would be one less than the next subnetwork address, right? Always broadcast address is one less than the next subnetwork. So the easiest way to find the broadcast address, it's basically by keep incrementing. So here we can see we were incrementing by 64 on the last octet because we are on the last octet, the cut line here, right? So 64 plus 64, 128. So here, this is our next subnetwork. One less than 128 would be 127, right? So that's the broadcast address, 192.168.5.127. And then here we have all these IP addresses in between. These are the usable IP addresses, all the available IP addresses that we can assign to the network devices on the network. So here the first usable IP address is just one IP address after this one. Therefore, would be 192.168.5.65 because .64, that's this network address. .65 is the first available IP address. 2, it goes to 192.168.5.1 less than broadcast 126. So these are the available IP addresses for this subnet. And looking at this IP address 192.168.5.118, it will fall in between these IP addresses, between the 5.65 to 5.126, which is kind of closer to the end, the 126. So if we had these type of questions that they gave us the IP address with the CIDR notation, and they asked what is the network address or what would be the network increment. So the network increment is 64. The network address is 192.168.5.64. The first available IP address is this. The last available IP address is this. And the broadcast address is this for this IP address. And the subnet mask is 255.255.255.192. In this example, they gave us one IP address and then they gave us a subnet mask and then they asked what is this address based on this subnet mask. So what we need to do first, we have to take a look at the IP address and then looking at the first octet. In this case, the first octet 192. 192, that's class C. And what is default subnet mask for class C is 255.255.255.0. That's a default subnet mask for class C. It means the first, second, and the third octet belongs to the network and the last octet belongs to the host. Okay, now here they gave us this subnet mask instead of this. So we know they didn't use the default subnet mask. Therefore, this address with this subnet mask, this is classless subnet mask, not classful, not the default subnet mask. So this is not a default subnet mask. Now what is this address? So in order to find out the next step, it's basically converting these subnet masks into the binary and then writing down the binary format here to find out our cut line. So where is all the ones and where is the cut line, where is all the zeros? Okay, so the first octet here, 255. So if we erase this one, so the first octet in our subnet mask here, 255. This means all the 8 bits turned on. So in the first octet, all the 8 bits turned on. Because anytime in any octet, if we have all the 8 bits turned on, the decimal value is 255. Where this 255 is coming from, if we add all these decimal numbers. Because ones, we just need to add the ones that are already being turned on. In this case, 1 is on, 0 is off. So in this binary, 1 means on. And if you have any question regarding how to convert binary to decimal or decimal to binary, please watch my other videos. I have full video demonstration going over binary to decimal, decimal to binary, and different number systems conversions. Okay, so here the first octet 255, we have all the 8 bits turned on. The second octet 255, let's go over. We have all the 8 bits turned on a second octet. And the third octet 255, we have all the bits turned on for the third octet here. And then we have 240. So this 240, what does it mean? We just need to convert this decimal to binary, which again, it basically means that the first 4 bits turned on. If I quickly show you guys going from decimal to binary, so if we have our 8 bits, and decimal values 1, 2, 4, 8, 16, 32, 64, and 128. These are the decimal values, and where these decimal values coming from, all these decimal values, where they're coming from, it's basically 2 to the power of bit position. 2 to the power of bit position. And 2, why 2? Because of the binary. We have ones and zeros, which again, on the previous videos, I talked about a lot more in detail. So, but quickly to show you guys here, we have 240, we just need to write down 240. And then going from left to right. So we have to see if this number 240 decimal value, if it's greater than or equal this decimal value, we just need to turn on. So in this case 240, it is greater than 128. So this one is on. Now what is our new value? 128. If we take out 240 minus 128 is 112. That's our new decimal value. So 112, let's write down here. 64. Is 112 greater than or equal 64? It is greater than, so it's turned on. And what is our new value? Minus 64, which is 48. This is our new value. So I'm going to write down here 48. So this 48, is it greater than or equal 32? It is greater than, so it's turned on. So 32. What is our new value? 16. So 16, let's write down here. Does this 16 is greater than or equal this 16? It is equal, so it's turned on. Minus 16, it's off. Now this is our new decimal value. So is this greater than or equal 8? Pretty much it's not, so it's off. And what about for 4? Does this greater than or equal 4? It's not greater than or it's not equal, so it's off. Does this greater than or equal 2? It's not, so it's off. The rest of them pretty much is off. When we have 0, the rest of them is off. Okay, so for 240 decimal gives us 11110000 binary number. And if we use calculator, we can see as well. So let's change the view to programmer view and making sure decimal is selected. So decimal value of 240. And here we can see the binary number 11110000, which again on previous videos I talked about this more, how we can convert decimal to a binary or binary to decimal, or pretty much any number system how we can convert. Just to quickly show you guys, this is the binary for 240. Let's erase. So it is 1 1 1 1 and 0 0 0 0. So originally for the default subnet mask of 192.168.1.47, because 192 it's class C, the default subnet mask was 255.255.255.0. It means the first 3 octet belongs to the network and the last octet belongs to the host. But right now with 240, it means that we basically borrowed 4 more bits, 1 2 3 4, right? So when we convert a 240 decimal to binary, this was our binary. Therefore our new cut line is this one. So we moved this original cut line from left to right. That's an example of subnetting. Anytime when we move this cut line to the right, and by the way, when we move it to the right, we will have less number of IP addresses. and we will have more number of subnets. When we move the cut line to the left, we will have more number of IP addresses but less number of subnets. We will talk about it more. That's known as supernetting, when we move the cut line to the left. Right now we are moving this cut line, the original cut line, to the right. So that's subnetting. Okay, so what was the original question? They gave us this IP address and this subnet mask, and they said, what is this address? Is this a network address, IP address, broadcast address? What is this address? Let's find out. What we need to do, we have to start from the zero network. And what is zero network? Basically looking at the IP address and apply its default subnet mask, 192.168.147. The 192 is class C, so the zero network for class C, we keep the network portion, and for the host portion we put 0. That's a zero network. So for example, the zero network for this address would be 192.168.1.0. This is the network portion, this is the host portion. For the host portion we just put 0. When we talk about zero network address, this is an example of zero network address. Okay, so what we need to do next, looking at these bits, the last bit that is turned on, what is the decimal value for the last bit that is turned on? In this case, this one is the last bit turned on, so the decimal value is 16. This is our network increment. On what octet? We are working on the last octet. The cut line here is on the last octet, network increment 16 on the last octet. So here, this is our last octet. So we are incrementing by 16, 192.168.1.16. Let's continue incrementing 192.168.1.16 plus 16, 32. If we continue incrementing by 16, so the next one would be 192.168.1.48. If we continue incrementing 192.168.1.64. Do we need to continue incrementing? We don't, because 47, it's already less than 64. We don't need to continue, but if we want, we just simply continue incrementing by 16 here for the next subnets. Now take a look at this address that they gave us earlier. So 1.47, 1.47, is it between 0.16? No. Is it between 16.32? No. Is it between 32.48? Well, it is. It's between 32 and 48, right? It's not in this one, because the 48 plus 1 is 49. So this 47 is one less, right? So therefore it's on this one. So, all right, let's see. Oh, okay, so if we talk about, this is the subnet of 1.32, well, with the broadcast address always one less than the next subnet. So the next subnet, in this case 192.168.1.48, so one less IP address would be 192.168.1.47. And then any IP address here in this range, these are the available IP addresses. Therefore, this address 1.47 here is the broadcast address. This 192.168.1.47 is the broadcast address for 192.168.1.32 subnet address. So again, if we had the multiple choices, what is this address? Is this a network address? Is this an IP address? Is this a MAC address? Is this a hexadecimal address? Is this a broadcast address? The correct answer would be, this is the broadcast address based on this subnet mask that they gave us. Now we can continue and write down the first available IP address, the last available IP address, and how many subnets we have, how many hosts we have per subnet. But they didn't ask that question. But to show you guys, the first available IP address in this subnet would be 192.168.1.33, and it goes to the last available IP address in this subnet would be 192.168.1.46, one less than broadcast. So how many available IP addresses do we have? Always we can count at the bottom going from right to left, starting with number 2, 2, 4, 8, 16, minus 2, 14. So these are the number of available IP addresses that we can have per subnet. Now, number of subnets, we can apply the same counting going from left to right, starting with 2, 4, 8, and 16. We don't need to do the -2 when we are counting the zero network as well. So it gives us a total of 16 available subnets. How do we know? If we are keep incrementing by 16, it will be total of 1, 2, 3, 4, 5, 6, 7, total of 16 available subnets. Also earlier we talked about the formula, number of subnets. It's basically 2 to the power of subnet bits, and number of hosts, 2 to the power of host bits minus 2, which in this case for number of subnets, 2 to the power of what? 1, 2, 3, 4, which gives us 16. And for the host, number of hosts, how many host bits do we have? 1, 2, 3, 4. So zeros, it's the host bits. And again, ones, network bits, and here, after the original subnet mask, when we borrow any bits from the host, these are known as a subnet bits, right? So these are the host bits. Zeros represents the host bits. So how many? We have 4. So 2 to the power of 4 minus 2, total of 16 minus 2, we have 14. So 14 available IP addresses per subnet. And how many subnets we have? 16 subnets. Here we can see 2, 4, 8, 16, and number of hosts 2, 4, 8, 16 minus 2 because of the network address and a broadcast address. This is a broadcast address. Network address we cannot use and assign to the computers on the network. So these are the only available usable IP addresses that we can utilize and assign on the network. That's why we do the -2. So again, per subnet we have total of 14 available IP addresses. In this exercise, they gave us network address and a default subnet mask, and they are asking for 32 available IP addresses per subnet. 192.168.1.0, the network address and a default subnet mask. This is class C, right? So 255.255.255.0. So we know 192, this is class C network. Default subnet mask for class C is 255.255.255.0, and this default subnet mask will give us up to 254 available IP addresses, but they are asking for 32 available IP addresses per subnet. So what we need to do, we have to subnet, and previously we talked about the number of hosts. So number of hosts, 2 to the power of host bits minus 2. Or we also said if we count at the bottom going from right to left, starting with 2, 4, 8, 16, 32, then we can find the number of hosts. Okay, so they are asking for 32 number of hosts per subnet. Okay, so here we might say, all right, this is enough, 32. That should be, it will give us 32 available IP addresses. But remember, we have to take out one IP address for network address and one IP address for broadcast address. So when we do the -2, we get 30. So we cannot stop here on this bit. We have to continue one more. These are type of tricky questions that basically one should make sure that we already know when we talk about available IP addresses. We have to do the -2, one address for the network address and one address for the broadcast address. Therefore, here at 32, it's not enough. It doesn't give us 32 hosts. It will give us a total of 32 correct. But when we do the -2 to see the available IP addresses, it will be 30. So let's erase all this and let's continue. So 2, 4, 8, 16, 32, 64. Now 64 minus 2 is 62. And 62 meets the minimum requirements, and we're not wasting too many IP addresses as well. Therefore, we can stop right here. So originally, class C network, class C subnet mask, we have 255. This is binary 255, first octet. And then second octet also 255. This is the binary for the 255 8 bits all turned on. When we add all this, that's 255. And this is also 255. So 255, 255, 255, 0, right? But what happened here, we borrowed 2 bits from the host bits. So now when we count the number of ones, so this is 8 plus 8, 16, plus 8, 24, 25, 26. So our new subnet mask will be 255.255.255. Here we have these 2 turned on. So 128 plus 64, 192. So all the 8-bit turned on, that's 255. Second octet, all the 8 bits turned on, that's 255 on the second octet. Third octet the same, all the 8 bits turned on. On the last octet, we have only 2 bits turned on, which gives us 192 when we convert this binary to decimal. Now we will have multiple different subnets, each subnet up to 62 available IP addresses. Yes, they did ask for the number of 32 available IP addresses, but we couldn't stop here because when we do the -2, one address for network, one address for broadcast, then it will give us 30 available IP addresses. But here they are asking 32 available IP addresses, so we had to continue one more bit to the left here for the host bits. So now we have 1, 2, 3, 4, 5, 6 host bits. Let's see. So 2 to the power of 6 minus 2, this is 64 minus 2, 62. So if we go by 2, like let's say if we stopped here, it will be 1, 2, 3, 4, 5, right? 2 to the power of 5 minus 2, 32 minus 2, 30. So this is not enough. They are asking for 32. This one is enough. Therefore, the number of host bits should be 6. And as we can see here, 1, 2, 3, 4, 5, 6 host bits. The rest of them is network bits. So basically 1s represent the network bits and 0s represent the host bits. So what is the CIDR notation? If we count all the 1s, it is 26. So 1, 2, 3, 4, 5, 6, 7, 8 plus 8, 16 plus 8, 24, 25, 26. So having network address of 192.168.1.0 with the subnet mask of 255.255.255.192 or the CIDR notation of 26 will give us 4 subnets, each subnet 62 available IP addresses. Now you might say where the 4 subnets coming from. As earlier we talked about the number of subnets, 2 to the power of subnet bits. So how many subnet bits we have here? These are the subnet bits. All this, it's a network bits. All this, these 2 subnet bits, and here all zeros. That's host bits. Okay, so 2 subnet bits, right? So 2 to the power of 2, that's 4. So it gives us 4 subnets. Each subnet, we can have up to 62 available IP addresses. So let's erase this one. And now let's see these 4 subnets in action. So I'm going to go ahead and erase all this. So if we write down our IP address, 192.168.1.0, what would be the next subnet? We have to increment by using the increment ID, which the last bit is turned on. The decimal value of the last bit turned on, that's our network increment. So 64 in this case on the last octet. This is the cut line. We are working on the last octet. So this is our last octet. We are incrementing by 64. The next subnet would be 192.168.1.64. The next subnet would be 192.168.1.128. And the next subnet would be 192.168.1.0. If we continue incrementing by 64, so 128 plus 64, 192. And the next subnet would be 192.168.1.256. So again, we don't have 256, that's invalid IP address. So here we can see subnet 1, subnet 2, subnet 3, and subnet 4. Or we can just simply start from here, going from left to right, starting with number 2, here the subnet bits, so 2, 4. So we will have 4 subnets, each subnet up to 62 available IP addresses. Now let's see all those 62 available IP addresses per subnet. So if we write down the range, this is the network address. Let's write down the broadcast address for the first subnet. Always the broadcast address is one less than next subnet. So the next subnet is 1.64. So one less would be 1.63. Let's write down 192.168.1.63. And here the first available IP address would be 192.168.1.1, and it goes to 192.168.1.62, one less than the broadcast. So here, these are the available IP addresses. Here is the network address, and here is the broadcast address. All these IP addresses in between, these are the 62 available IP addresses, which we can see 1.1, 1.2, 1.3, and it goes to up to 1.62. After that, we have 1.63, that's a broadcast address, and then the next one, 1.64, that's the next subnet based on this subnet mask. So this subnet mask will give us the network increment of 64. How? Because when we convert this subnet mask into the binary, this 255 on the first octet, that's all the 8 bits turned on. This 255 on the second octet, all these 8 bits turned on. These are the binary. So when we convert this binary to decimal, that's 255. Where is it coming from, this 255? Since all of the bits turned on, we have to add all these decimal values. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 and plus 1. So that's 255. Now, same thing. On the third octet, all the 8 bits turned on. That's 255. Here we can see on the third octet. And then on the fourth octet, 192. So only these two turned on. 128 plus 64. That's 192. The rest of them, it's 0. So the rest of them is 0. And zeros is host bits. So ones represent network bits and zeros represent the host bits. And these are, we talked about the number of hosts. We can also count at the bottom starting with 2, going from right to left, 2, 4, 8, 16, 32, 64, minus 2 to get the total number of available IP addresses per subnet. And if we want to find out how many subnets we have, in the subnet bits, starting with 2, going from left to right, 2, 4. That's the total number of subnets we can have. We can have 4 subnets, every subnet, 62 available IP addresses. And here we can see these are all the network addresses incrementing by 64, which gives us up to 4 different subnets, because this fifth one, that's 256, that's not correct. And each subnet we can have 62 available IP addresses, and this is the broadcast address for this subnet. So just remember, when they give us the actual block size, when we do the -2, these are those type of tricky questions that we have to be careful. Here they said we need 32 hosts. So when we count 2, 4, 8, 16, 32, when we do the -2, for one address for the network address and one address for the broadcast address, it's reserved. We cannot use them. We cannot assign them to the network devices. So when we do the -2, it's not going to be enough IP addresses. 32 minus 2 is 30. And here they are asking for 32. So that's why we had to continue one more block. So here we can see 64. And when we draw a cut line, 64 minus 2 here, 62, that's pretty much more than enough. And we're not wasting too many IP addresses at the same time. We are meeting the minimum requirements they're asking for and not wasting too many IP addresses. In this example, they gave us network address, default subnet mask, /24, the CIDR notation of a default subnet mask class C. And then they are asking, we need 4 subnets. So we know by default, class C network, the subnet mask is 255.255.255.0. And this is just one network, the 192.168.1.0 network. So we want to break this big network into multiple smaller subnetworks. And here they are asking we need 4 subnets. So how can we do that? Well, the first step, we need to write down the default subnet mask. So what is the default subnet mask for class C? 255.255.255.0. This is the decimal format. So if we convert this to the binary, the first octet 255, that's 8 ones. So let's write down, because again, all these ones, when we add all these decimal values, it gives us 255. That's basically converting binary to decimal. I have complete crash course regarding all those number systems, how we can convert. If you haven't watched those videos, please make sure go back and watch those videos first. So here we are converting this binary to decimal. This decimal value of 255, it's equivalent to having 8 bits all turned on. Okay, this octet, the second octet, 255, same thing. We have 8 bits already turned on. And a third octet here, 255, same thing. And this is the original code line. These are turned off. So here we can see on the last octet 0. So all the 8 bits turned off. And here we can see all these ones, that's network bits, zeros, host bits. And if we count all the number of ones, it should be 24. This is the default CIDR notation for class C network. How do we know this is class C? Because looking at the IP address, the first octet, 192. 192 falls into class C network. Okay, now they are asking for 4 subnets. As we talked earlier, the number of subnets, it's basically 2 to the power of subnet bits. So we need how many? 4. So basically 2 to the power of, let's say, x equals 4. And this is just basic math. You guys remember? We learned about all this. So if in order to find the x, we just need to divide. So x equals 4 divided by 2, which is 2. So this is the number of subnet bits. 2 to the power of subnet bits equals whatever value. So they gave us, we need 4 subnets. So how many subnet bits do we have to get, right? In order to get the subnet bits, here 4 divided by 2 equals 2. So basically we need 2 subnet bits. Or in other words, as I mentioned earlier, to find the number of subnets going from left to right, starting at the bottom, starting with number 2, 2, 4. That's it. This is the number of subnet bits. 4. We can stop here. And the number of hosts we talked about going from right to left, starting with number 2, and then 4, 8, 16, 32, 64, and we have to do the -2 to find available IP addresses. 64 minus 2, 62. So in this example, we will have 4 subnets. Every subnet we will have 62 available IP addresses per subnet. So let's go over these subnets. Well, if we start from the 0 network, 192.168.1.0, and now let's write down the next subnet. The next subnet would be 192.168.1.64, where the 64 is coming from. Well, we have to take a look and see the last bit that is turned on. We borrowed how many bits? 2 bits, right? So let's erase this 2 and let's turn on these 2. So the last bit we borrowed, the decimal value is 64. This is our network increment or block ID. So 1.0, 1.64 on the last octet, because the cut line is on the last octet. In the next exercises, we will do the subnetting on class B or class A you will see then we will work on the third octet or on the second octet where the cut line is, then we just need to increment on that block. This one is a class C subnetting, and here we can see we are working on the last octet. So the cut line is on the last octet and incrementing by 64 on the last octet. So the next subnet would be 192.168.1.128. And the next subnet would be 192.168.1.192. And the next one would be 256, which 256 not valid. Therefore, these are our 4 subnets. And each subnet up to 62 available IP addresses. For example, if we take a look at the first subnet here, let's write the broadcast. Always the broadcast is one less than the next subnet. Next subnet is 1.64, therefore should be 1.63. So 192.168.1.63. And the range, first available IP address for this subnet is 192.168.1.1, and it goes to 192.168.1.62. So 1.1, 1.2, 1.3, and so on to 1.62. These are the 62 available IP addresses we can see in every subnet. Same thing, here we will have 62 available IP addresses in this range. So this is our network address here, our network address, and here is our broadcast address. And here in between, these are all the available IP addresses that we can use and assign to the computers, interfaces, basically to the network devices. So to quick recap, what was the question? They gave us the network address, default subnet mask, and they said we need 4 subnets. So what we had to do first making sure what class this is. This is class C. What is the default subnet mask for class C? 255.255.255.0. Why this is class C? Because looking at the first octet, 192 falls into the class C range. And drawing the default subnet mask cut line here, this is the default subnet mask because 24 bits it's for the network and 8 bits for the host. And then we had to borrow from the host bits. So we borrowed 2 bits. Why? Because when we borrow 2 bits, it will give us 4 subnets. We had this formula, 2 to the power of subnet bits. That's the number of subnets. In this case, 2 bits, right? 2 to the power of 2 equals 4. And the number of hosts at the bottom, going from right to left, starting with number 2, 2, 4, 8, 16, 32, 64. 64 minus 2. Why minus 2? Because 2 addresses we cannot use, we cannot assign to the computers on the network. One address is the network address and one address is the broadcast address. So this column is the network address column, and this column here, these addresses are broadcast addresses. That's why we need to do the minus 2. For the subnet, we don't do the minus 2 because we are counting the 0 network as well. So for the subnet, we don't do the minus 2. For the host, we do the minus 2. Or if we go by this formula, the number of hosts, 2 to the power of host bits minus 2. So how many host bits? 1, 2, 3, 4, 5, 6. Zeros are host bits. So 2 to the power of 6 minus 2, which is 64 minus 2, 62. So after finding out how many bits we need to borrow from the host, in this case 2 bits to get 4 subnets, right? Then we draw a cut line. So this is our new cut line. Originally, this was our default subnet mask, right, for class C network, but we moved this cut line 2 bits over. Now this is our new subnet. So what would be our new subnet mask? It is not 255.255.255.0 anymore. if we convert this binary to decimal, 128 plus 64, that's 192. So it would be, let me erase this one on the last octet. So it would be 255.255.255.192. That's our new subnet mask. And of course, it's not 24 anymore. That would be 26. Where 26 is coming from, if we count all these ones up to here, is 26 ones. So 8 plus 8 plus 8, 24, 25, 26. And the zeros, they are host bits, which here we have 6 bits for the host and we have 26 bits for the network. 26 bits for the network, which this will give us a total of 32 bits. That's IP version 4. How many bits we have in IP version 4? 32 bits. So this 26 bits would be our new network bits. Therefore, the new CIDR notation would be /26. And of course, our new subnet mask will be 255.255.255.192. 192 if we convert this binary to decimal. So here we have 2 bits on and we have 6 bits off. When we convert this binary to decimal, it is 192. Basically, we just need to add the decimal values that are already being turned on. In this case, 128 and 64 turned on. So 128 plus 64 is 192. And the last bit that is turned on, the decimal value for the last bit, that's our network increment. So starting from 0 network, 1.0, we are incrementing by 64, 1.64, 1.128, 1.192. We can't continue because we get to 256, we don't have 256. Every octet, the range goes from 0 to 255. 256, not valid. So these are the 4 subnets. And of course, every subnet, 62 available IP addresses. On this video, I just wanted to go over multiple different types of questions that you might see when we talk about subnetting. So one type of question you might see, let's say, I'm going to write down question 1. Let's say they might give you network address 192.168.1.0 with the default subnet mask. Of course, this is class C, so it would be 255.255.255.0, and they might say we need 50 number of hosts. We don't need 254 because by default class C, going by default subnet mask, gives us 254 available IP addresses. So this is one type of question you might see. Another, let's say I'm going to write down question number 2. They might say, okay, this is our network address 192.168.1.0, default subnet mask. Of course, this is class C, right? 192 class C network. Default subnet mask is 255, 255, 255, and 0. And they might say we need 10 different subnets. We know the default 255.255.255.0, that's just one network. So this is 192.168.1.0 network. All the IP addresses in this network, they can communicate. They can talk together. This is just one big network with 254 available IP addresses. So they want 10 different subnetworks. For example, let's say to use one subnet for accounting department, one subnet for marketing department, one subnet for the sales department, and so on. Another type of question you might see, I'm going to write down question number 3. They might give us IP address. So I'm going to write down 192.168.1.68, for example. And they might give us a CIDR notation, let's say 29. And they might say, what is this address? If this is IP address, this IP address belongs to what network? If this is a network address, let us know if this is the broadcast address, that the broadcast address belongs to what network. They might give us one IP address with the CIDR notation, and depends what type of question they might ask after that. But we will go over all of them. And then another type of question, I'm going to write down question number 4. They might give us IP address 192.168.1. Let's say 118, and they might give us a subnet mask of 255.255.255.192. And they might say this IP address belongs to what network. So these are different types of questions that you might see. For this example, I just used class C network, and in the future we will go over class B and class A IPv4 subnetting. Okay, first let's go over question number 1. Question 1. For question 1, they give us the network address of 192.168.1.0 with a default subnet mask of 255.255.255.0 because this is class C network address, and the default subnet mask for class C, as we can see here, 255.255.255.0. And they are saying we don't need 254 available IP addresses. We only need 50. We don't want to waste all those additional IP addresses. So what we have to do first? Well, here they are asking number of hosts 50. And earlier we talked about in order to find out the number of hosts. So number of hosts 2 to the power of host bits minus 2. So we also talked about going from right to left at the bottom, starting with number 2. That's the number of hosts. So 2, 4, 8, 16, 32, 64. They are asking for 50. This block 64, it's perfect. So 64 minus 2 is 62. Let's erase this. 62. So 62, it's enough IP address. Basically, it meets the requirements. They are asking for 50, and we are not wasting too many IP addresses. So we can draw our cut line here. So the original, the subnet mask was 255, class C default subnet mask, right? 255 and 255.0. But what happened here? We borrowed 2 bits from the host bits. So the original cut line was here, and we moved the cut line 2 bits to the right. Anytime when we are moving the cut line to the right, that's subnetting. When we move the cut line to the left, that's supernetting. We will go over supernetting in the future videos. So all the additional bits here, it's pretty much off. These are the host bits. Zeros, host bits, ones, network bits. And of course these two, these are our subnet bits. So all the network bits here, and these 2 subnet bits, and here all these zeros, host bits. And that's it, we just solved the problem. So here, when we have the cut line, the last bit that is turned on, this is our network increment. In this case, 64 is our network increment on the last octet. The network address here they gave us 192.168.1.0. So if I write down 192.168.1.0, what is our new subnet mask? So we borrowed 2 bits here, right? So it's 255.255.255 on the last octet. On the last octet here, 2 bits we borrowed. So 128 plus 64, that is 192. So the subnet mask is 255.255.255 and 192. That's our new subnet mask. And the Saturn notation is 26. So up to here, the original default subnet mask for class C is 24 bits. 8 plus 8, 16 plus 8 ones here, 24. And these 2 borrowed from the host bits. So it's turned on now. It's part of the network bits basically. So 24 plus these 2, 26. So the Saturn notation is 26. And the increment, the last bit turned on, decimal value is increments, 64 on the last octet. So if you want to write down 192.168.1.0, our first subnet, 192.168, 1. Incrementing by 64, and then 192.168, 1.128, 192.168, 1.192, and that's it, because the next one is 192.168.2.0 or 192.168.1.256, but 256 we don't have. These are the 4 subnets, and every subnet we can have up to 62 available IP addresses, which yes, again, they ask for 50, but remember it goes by block numbers, And this block is the closest one that meets the requirements, 62 available IP addresses, and not wasting too many IP addresses. So again, the number of hosts, 2 to the power of host bits minus 2. How many host bits? 1, 2, 3, 4, 5, 6. All these zeros considered host bits, ones considered network bits. So we have 6 host bits, 2 to the power of 6 minus 2, which is 64 minus 2, it is 62. Every subnet, we have 62 available IP addresses. To show you, let's erase all this. In order to find the range, it's better to have the network address and the broadcast address, and then we can write the available IP addresses in between. So the broadcast address is 1 less than the next subnet. Next subnet is 192.168.1.64. One less IP address is 192.168.1.63. So let's write down here 192.168.1.63. That's our broadcast address. And the first available IP address, 192.168.1.1. And it goes to 192.168.1.62. So 1.1 to 1.62. And here, as we can see, every subnet gives us 62 available IP addresses. They are asking for 50. Very good. We have even a couple more IP addresses just in case, but we are meeting the minimum requirements. On this subnet, exactly the same. We will have 62 available IP addresses. And a broadcast address for this subnet would be 1 less than the next one, which is 1.127. 1.127. So 192.168.1.127. And same thing, the first IP address, the first usable IP address would be 192.168.1. This is 64, so it would be 65. And it goes to 192.168.1. This is 127, one less than broadcast address, 126. That's the range. So 1.65, 1.66, 1.67, and so on. And when it gets to 1.126, that's the last available IP address. 1.127, that's the broadcast address. And 1.128, that's the next subnet address. So the network address of 192.168.1.0 with the subnet mask of 255.255.255.192 will give us 4 subnets. Each subnet we can have up to 62 available IP addresses. Quick recap, this was for question number 1. Question number 1, they gave us a network address, default subnet mask, asking for 50 hosts. What we did, first finding out how many bits do we have to borrow from the host bits in order to subnet, and having enough number of IP addresses, available IP addresses. So in this case, 2. Why from here again, class C, default subnet mask, we have 24 ones. So previous videos we talked about the default subnet mask for class A, B, and C. So this is the default subnet mask for class C up to here. That's the default cut line. So these are zeros, the host bits. We borrowed 2. And now we have 6 host bits. So 2 to the power of 6 minus 2 gives us 62. And 62, it covers the 50 hosts. We will have 62 available IP addresses, and this will give us 4 subnets. Let's go over the next question. So I'm going to erase all this. So question number 2. For question number 2, they give us a network address 192.168.1.0 and default subnet mask, but they are saying 10 subnets. Because by default, 192.168.1.0 and the default subnet mask gives us one big network. But we need 10 subnets. So what we need to do, first we have to go through the default subnet mask. This is the default subnet mask, our cut line, right? And then finding out the 10 subnets. For subnetting, we have to move the cut line from left to right. So how many bits? Let's find out. We talked about at the bottom, if we go from left to right for the number of subnets, left to right. So starting with number 2, 4, 8, 16. That's it. So they're asking for 10 subnets. We are going by blocks. So 2, 4, 8, 16. These are the number of subnets. This 4 bits, it covers 16 subnets. So we had to borrow these 4 bits. And these are all off. Now this is our new cut line. So we can erase this one. So how many ones do we have now? Up to here, 24, plus this 4, 28. So the network address of 192.168.1.0 with the new subnet mask, if we convert all this binary to decimal, is 255, 255, 255, 240. Where this 240 is coming from? On the last octet, we see 1, 2, 3, 4 bits turned on, and these 4 bits turned off. So if we add 128, 64, 32, 16, basically we just need to add the ones that are already being turned on. So 128 plus 64, that's 192. 192 plus 32, that's 224. 224 plus 16, that's 240. So this is our new subnet mask. And a shorthanded version, and by the way, this is 5, it looks like 1. And the shorthanded version is / counting all the number of ones. So up to here, 24, 25, 26, 27, 28. So this will give us 16 different subnets. They are asking for 10, yes. But when we go by block size, if we stop here, it will give us up to 8 subnets. They are asking for 10. So we have to go one more. Here now it gives us 16. Very good, meets the requirements, and we have a couple more subnets in the future that we can use as well. Now let's see these subnets. Okay, so the last bit that is turned on, what is the decimal value? So the last bit that is turned on, these are the decimal value at the top. 16 is the decimal value for the last bit that is turned on. So this 16 is our network increment on the last octet. So let's write down our network address 192.168.1.0. This is a 0 network. The next subnet would be 192.168.1.16. The next subnet would be 192.168.1.32. We are keep incrementing by 16. Why 16? Because after finding the cut line, the last bit that is turned on, the decimal value is 16. That's our network increment or block ID. Because we are on the last octet, we are incrementing on the last octet by 16. And why did we draw a cut line here? Because they were asking for 10 subnets, right? So we know the default subnet mask for class C, 192 is a class C. The default subnet mask is up to here. 24 bits. Ones. These are 1, 8 plus 8, 16 plus 8, 24. The cut line was here, right? So we had to see how many more bits we can borrow from the host to have minimum of 10. So the closest one, if we borrow 4 bits from the host, which gives us 16 subnets. And again, we talked about the number of subnets. It's 2 to the power of subnet bits. So in this case, how many? 1, 2, 3, 4. 2 to the power of 4. That's 16. Or we can just write down, going from left to right for the number of subnets, 2, 4, 8, 16. Earlier we talked about the number of hosts going from right to left. Right to left. For the number of hosts, starting with 2, 2, 4, 8, 16 minus 2. We had to do the minus 2, 14. So we know we will have 16 subnets. Every subnet we can have up to 14 available IP addresses. And now we are going through the subnets. So this is the first subnet, the second subnet, the third subnet. The next one would be 192.168.1. We have to keep incrementing by 16, right? So 32 plus 16, 48. 192.168.1.64. 192.168.1.64 plus 16, 80. 192.168.1.80 plus 16, 96. How many we have? 1, 2, 3, 4, 5, 6, 7. They said 10. So we have to continue incrementing by 16. So the next subnet would be 192.168.1.96 plus 16, 112. Next one I'm going to write down here. So the next subnet would be 192.168.1.128 because 112 plus 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's write down 192.168.1.128 plus 16, 144. That's it. These are our 10 subnets, including the zero network. So if we need more subnets, we can continue incrementing by 16. But of course, we know this will give us up to 16 subnets. When we get to 256, that's where the invalid IP address. So to quick recap, for this question number 2, they gave us the network address and the default subnet mask, and they said we need 10 subnets. So what we did, writing down the network address, and then going through the default subnet mask up to, because this is class C, we know the default subnet mask is 255.255.255.0, so that's 24 bits of 1, and these are the 24 bits on, and this is the cut line here. But here asking for 10 subnets, so from the host bit we had to borrow 4 bits. 1, 2, 3, 4. So when we borrow 4 bits, it gives us 16 subnets. If we borrow 3 bits, it will give us 8 subnets. 8, it's not enough. So they are asking for 10 subnets. That's why we had to continue, and the next block is 16, so it will give us 16 subnets. And the last bit turned on, the decimal value also is 16. Therefore, the increment on the last octet, we are working on the last octet, the cut line is on the last octet, right? So incrementing by 16. If we start writing our network address, the zero network, 192.168.1.0, and keep continuing incrementing by 16, the next one would be 192.168.1.16, the next subnet would be 192.168.1.32, the next subnet would be 192.168.1.48, and so on. And each subnet, we can have 14 available IP addresses. For example, quickly, if I show you on, let's say, this subnet. And so the next, in order to find out the range, the easiest way to have basically the network address and having the broadcast address. How can we find the broadcast address? Finding the next subnet. How can we find the next subnet? By incrementing, right? Okay, so 64, we're incrementing by 16. This is 80. This is just one example I'm showing on this subnet, and to see the number of available IP addresses and the broadcast. So the broadcast for this subnet would be 1 less than the next subnet. So if the next subnet is 1.80, the broadcast should be 1.79. So 192.168.1.79. Now 64 is the network address, 79 is the broadcast address. So any IP addresses in between, these are the available IP addresses. What would the first available IP address? 192.168.1.65. 2, 192.168.1.78. So if we count 65, 66, 67, let's count. So if we count 65, 66, 77, and 78, these are 14 available IP addresses, which here we did find out 14 available IP addresses by using this method we talked about earlier, going from right to left, starting with number 2, 2, 4, 8, 16 minus 2, 14. Why minus 2? Because of the broadcast and the network address we cannot use. So when we do the minus 2, we have the available IP addresses that we can use and assign to the computers on the network. So here should be 14 available IP addresses. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these are the 14 available IP addresses. Of course, goes from 1.65 to 1.78 on this subnet. Exactly the same On the other subnet should be 14 available IP addresses. And here we talked about left to right number of subnets starting at the bottom going from 2, 2, 4, 8, 16. These are the number of subnets going from left to right. Going from right to left, the number of hosts. And for the number of hosts, we have to do the -2. And here the numbers to the top, these are the decimal values for these bits, which always is 1, 2, 4, 8, 16, 32, 64, 128, 1, 2, 4, 8, 16, 32, 64, 128 for the decimal values for these bit positions. So this was for question number 2. Let's move on to question number 3. I'm going to go ahead and erase. Okay, let's write down question number 3. Alright, so for question number 3, they give us IP address and with the SADR notation 29. So they said this IP address belongs to basically what network. Or another type of question, they might say, what is this address? Is this a network address? Is this a broadcast address? Is this IP address? Based on this SADR notation. So how can we solve this? Alright, so as we can see, this is still class C network, 192, right? But here, 29, that's a SADR notation, how many bits turned on for the network. So the default subnet mask for class C should be 24 bits turned on, which gives us 255.255.255.0 for the subnet mask, right? But this is not 24, it's 29. So what they did, they subnetted. So what we need to do, we need to count 29 ones going from left to right, right? 1, 2, 3, 4, 5, 6, 7, 8, up to here 16, up to here 24. Let's continue adding. So up to here 24, 25, 26, 27, 28, 29. And these are turned off. This is our cut line. So basically this /29 means we have 29 bits of turned on, that's a network bits, and we have 3 bits for the host. And 29 plus 3, that's 32. That's how many bits we have in IPv4. Total of 32 bits. So what's the next step? Well, you guys remember we talked about network increment. Well, here we can see the last bit that is turned on here. The decimal value is our network increment. So on the last octet. Now we need to write down the network address. So what would be the network address? Well, we have to start from the 0 network in order to be able to apply the network increment for the subnet, right? So this is the address they gave us. And if we pay attention to the first octet here, 192, so we already know this is class C. This is class C network. So what is the default subnet mask for class C? 255.255.255.0. Basically the ones that is 255.255, we just write down. So here 192, this is 168, and here 1. And here is 0. So for the host portion, 0, right? We just put 0. And this is the starting point. That's our 0 network, 192.168.1.0. Always I say that we have to start from somewhere, right? So this is our 0 network, so we can apply the network increment. Always we start with the 0 network. How can we find the 0 network? By using the default subnet mask. So when we have the default subnet mask, this is class C, this is default subnet mask. For the host portion, we just put the 0. The rest of them, we just put the actual value. So in this case, 192.168.1. 192.168.1. The host, we put 0. How do we know it's a host? Because 0 is the host. 255, it's the network. Okay, now let's go ahead and apply the increment. Incrementing by 8 on the last octet. So the next subnetwork would be 192.168.1.8. While with the next subnet, 192.168.1.16. While with the next one, 192.168.1.24. The next one would be 1.32. Next one would be 1.40. Next, 1.48. Basically, we have to keep incrementing by 8 to get to this value, basically, or see what is this value basically falls into what range. We know 68, it's not between 8 and 16. It's not between 16 and 24. You see? So it's not between 32 and 40. So let's continue incrementing. 48 plus 8, 1.56. 56 plus 8, 1.64. 64 plus 8, 1.72. Do we have to continue? Well, we don't, because here 68 falls into this range, right? Therefore, we know 68 it's in this network. So let's write down 192.168.1.64. And then let's write down the broadcast address for this subnetwork. Always I say this, the easiest way to find the broadcast address is to find the next subnet first. And then broadcast address is one less than next subnet. How can we find the next subnet? By applying the increment. So if the next subnet is 192.168.1.72, one IP address less than 1.72 is the broadcast address for this subnet. So 192.168.1.71. Now let's write the available IP addresses. So the first available IP address in this subnet is 192.168.1.65, and it goes to 192.168.1.70. So this 68 is one of the IP addresses in this range. Actually it is, well, if the first one is 65, the second one 66, the third available IP address would be 67, the fourth available IP address is 68. So we know 192.168.1.68 is the fourth available IP address in this range. So this CIDR notation of 29, it will give us a new subnet mask, right? So the default subnet mask for class C we talked about earlier is 255.255.255.0, but what is the new subnet mask? So here we can see 8 plus 8, that's 16, plus 8, that's 24. That's where the 255.255.255, right? All the 8 bits in this octet, we need to add all these decimal values. That's the 255 here. And here 8 bits turned on. All this we add. 255, same thing. So here we can see. But this 0, well, here we can see on the last octet, we have 1, 2, 3, 4, 5 bits borrowed from the host. So 5 bits, network bits, 3 bits for the host bits. Therefore, our new subnet mask is 248. Where this 248 is coming from, basically we are converting this binary number to a decimal number. 128 is turned on, 64 turned on, 32 turned on, 16 turned on, and 8 turned on. The rest of them turned off. 0, it's off. 1, it's on. So the one that is on, we just need to add. So if we add all these numbers, we get 248. And also we do have this chart. If you remember, earlier we talked about this. Anytime when we borrow 1 bit, that's 128. 2 bits, that's 192. 3 bits, that's 224. 4 bits, that's 240. 5 bits, 248. And here we can see 1, 2, 3, 4, 5 bits borrowed, right? So it's 248. And if 6 bits borrowed, it is 252. If 7 bits borrowed, 254. And 8 bits borrowed, 255. This is also a table. It's a good idea to memorize this and remember this. So anytime 1 bit borrowed, or let's say 2 bits borrowed, what would be the actual decimal value? Okay, quick recap. For question number 3, they gave us one address with the CIDR notation, and they said this address, what is it, or belongs to what network? Is this a network address? Is this a broadcast address? Is this IP address? If it's the IP address, belongs to what network? So what was the first step? We had to count. Basically, we had to apply this CIDR notation. 29, we know this IP address is a class C. 192, looking at the first octet, 192 falls into class C network, right? So we know this is a class C network, and the default subnet mask should be 24. This is 29. So we know this is classless. So what they did, they subnetted, right? So we need to count 29 going from left to right. So here, 1, 2, 3, 4, 5, 6, 7, 8, plus 8, 16, plus 8, 24, 25, 26, 27, 28, 29. And then draw a cut line. So this is our new cut line. Therefore, gives us a new subnet mask. So this 8 bits turned on, this is 255. This 8 bits turned on, when we add all these decimal values, that's 255, 255. And here on the last octet, we have only 5 bits turned on. So it gives us 248. And then, after getting our new subnet mask, we need to find our network increment. The last bit that is turned on, in this case, this is the last bit turned on. This is a decimal value. That's our network increment. We need to increment on the last octet, starting from the 0 network. So to find the 0 network, we just need to apply the default subnet mask. This is class C, 192.168.1.68. Looking at the first octet, we know this is class C, and the default class C subnet mask is 255.255.255.0. So for the host portion, we just put 0, 192.168.1.0. That's how we can find the 0 network. And then incrementing by 8 on the last octet. Since this is the cut line on the last octet, why it's here? Because of the number 29, right? 29 bits. Network bits turned on. If we count left to right, 29 ones, we end up here. So draw a cut line, and 3 bits 0, that's the host bits, all these ones, network bits, the last bit turned on, the decimal value is 8, that's our network increment on the last octet. Okay, so then incrementing by 8. We need to continue incrementing by 8 to see our host information, 68. In this case, 68 falls into the 64. So we know this IP address belongs to this 192.168.1.64 subnet. And then we can find the broadcast address. The broadcast is always one less than the next subnet. So after continue incrementing by 8 here, so finding the next subnet, 72. So 1.71 is the broadcast, and then be able to write the available IP addresses in between. So the first available IP address is 192.168.1.65, and it goes to 192.168.1.70, which, looking at this IP address 192.168.1.68, it falls into this range. Therefore, this is the network address, and this is the broadcast address. This is the first available IP. This is the last available IP. This is our new subnet mask, and of course the CIDR that they gave us earlier. Okay, now let's move on to question number 4. So I'm going to go ahead, erase. Okay, let's write down question number 4. Basically, it's kind of similar to question number 3, but instead of the CIDR notation, they gave us the actual subnet mask. So they gave us the IP address here, and they gave us the subnet mask. They said, basically this IP address, what is it? Is this IP address, broadcast, network, and if this is the IP address, belongs to what network? So what we need to do, so the first step, simply looking at the IP address 192.168.1.118, this address is a class C, because the first octet here, 192, it's a class C network, right? Earlier in previous videos, we talked about all the classes, class A, B, and C. Please make sure to watch those videos. And then here we can see the default subnet mask for class C should be 255.255.255.0, but this is not 0, so that's 192. What they did, they subnetted. That's an example of classless subnet mask, not classful subnet mask. Okay, so what we need to do, we need to convert 192 into the binary, which 192, it's basically 2-bit borrowed. In other words, it's basically 128 plus 64, that's 192. So we know these two turned on, and this is the cut line, and the rest of them it's off. So we have up to here 24 bits plus these two, 25, 26. So in other words, we can just simply write down /26. And then we have 1, 2, 3, 4, 5, 6 host bits. Okay, the next step is by looking at the last bit that is turned on. In this case, this is the last bit that is turned on. So the decimal value is 64. That's our network increment. We need to apply the same. We need to write down the 0 network for this one. You guessed it right, very good. This is 192. That's class C network. Default subnet mask 255.255.255.0, right? So for the host portion, we just put 0. So let's write down the 0 network, 192.168.1.0. And we are incrementing by 64. That's our network increment on the last octet. 192.168.1.64. And we can continue incrementing by 64. 192.168.1.128. So 128 plus 64. 192.168.1.192. And if we continue incrementing by 64, we get 256. So 192 plus 64, 256. We don't have 256. That's not a valid number. We talked about in IP version 4, every octet, we have the range from 0 to 255 because every octet we have 8 bits. And all the 8 bits, if all of them turned off, 8 bits 0, that's 0. 8 bits all turned on, that's 255. So we don't have 256. All right. So we know this subnet mask will give us 4 subnets. And looking at this IP address 118, so 192.168.1.118, let's see it falls into which subnet. 118 should be in the 64 subnet because 64 goes to 128, right? So 118 should be in this subnet. And if we write the actual ranges, so the broadcast address always one less than next one. The next one is 128, so it should be 1.127. Of course, 192.168.1.127. And here the first available IP address is 192.168.1.65. So I'm going to just write down 1.65 and it goes to 192.168.1.126. So 1.126, one less than the broadcast. And of course, the actual IP address 192.168.1.65 goes to 192.168.1.126. And this IP address of 192.168.1.118 with the subnet mask of 255.255.255.192 falls into this range. This 192.168.1.64 is the network address for this IP address. So this is another type of questions that you might see when we talk about all these subnettings. And if you want to continue, of course, this we just saw these 4 subnets, again number of subnets going from left to right, and then starting at the bottom counting from 2, 4, so 4 subnets, the number of hosts going from right to left, and then starting at the bottom 2, 4, 8, 16, 32, 64 minus 2, 62. So this CIDR notation of 26 or this subnet mask will give us 4 subnets. Every subnet we can have 62 available IP addresses. So previously we talked about subnetting. In this video we will go over more in detail regarding network bits, subnet bits, and the host bits. We will start with class A. So we already know the default range for class A. Class A, in the first octet, the range goes from 1 to 126. So when we see IP address, let's say 10.18.25.19, we know this is class A IP address. How do we know that? Looking at the first octet, 10 falls into this range. Therefore, this is class A. And default subnet mask for class A, it was 255.0.0.0. That's a default subnet mask for class A. The 255 means on the first octet, all the 8 bits turned on, that's the network bits, and zeros means host bits. So in this example, we have 8 bits for network bits and 24 bits for host bits. So this 10 is the network information and 18.25.19 is the host information. So for this IP address, the network address would be 10.0.0.0. So this IP address belongs to this network based on this default subnet mask. And this 18.25.19, that's the host information. Okay, but this is if we are using the default subnet mask. And also we talked about this is the decimal notation. The prefix notation would be /8 or the CIDR notation, CIDR, classless interdomain routing. So this is the class full. This is default subnet mask /8. That's a default subnet mask for class A. But now let's talk about the differences between network bits, subnet bits, and host bits. So I'm going to erase all this. So class A default subnet mask is 255.0.0.0. So we have /8 for the prefix. What does it mean? It means that we have 8 bits for the network bits. This is our cut line, and the rest it's the host bits. All zeros. So zeros represents the host bits, ones represents the network bits. Now where is the subnet bits? So anytime when we are using the CIDR notation, anything other than 8, let's say /12. What does it mean? We have to count left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we borrowed from the host bits. How many bits did we borrow? 4 bits. So all this default subnet mask, all the bits originally we had for the default subnet mask, these bits known as network bits. The bits that we borrowed from the host bits, or in other words, when we did subnetting, right? These are known as subnet bits. And the zeros means host bits. Now where is our new cut line? So our new cut line is here now. So I'm going to erase this one. Originally it was here based on default subnet mask, but with this CIDR notation /12, one example, let's say it was, they gave us the IP address with the CIDR notation of 12. So 12 bits for the network. Of course, the first 8 bits known as the network bits, these 4 known as the subnet bits, all of them it's a network bit, yes. But when we want to find out how many subnets we have to pay attention to the borrowed bits from the host bits. And always the subnet bits, it basically goes one bit after another, going from left to right. So previously we talked about to find out the number of subnets. We have this formula 2 to the power of subnet bits. So in this case, how many subnets do we have? 4. 1, 2, 3, 4. So 2 to the power of 4. And it gives us how many? 2, 4, 8, 16. And the number of hosts that we can have per subnet, 2 to the power of host bits minus 2. So how many host bits do we have? All the zeros, it's host bits. So let's count. 8 here plus 8 here, that's 16. 17, 18, 19, 20. 2 to the power of 20 minus 2. We have to do the minus 2 because of the network address and the broadcast address. We cannot assign them to the computers, network devices, and so on. These 2 addresses is reserved mainly for the network address and the broadcast address. So to find out the available IP addresses, we have to do the minus 2. So what is the value? 2 to the power of 20 minus 2. That's 1,048,576 minus 2 gives us 1,048,574. So that's how many available IP addresses we can have per subnet. And how many subnets we will have? 16 subnets. So this is not a default subnet mask for class A anymore. With this CIDR notation, so I'm going to go ahead and erase all this. It will give us a new subnet mask. What would be? So let's convert this binary to decimal. So all the 8 bits turned on in the first octet, that's 255. So our new subnet mask would be 255 dot. And here we have on the second octet, we have these 4 bits turned on. So we just need to add these 4, 128 plus 64 plus 32 plus 16. That's 240. dot, in this octet, we have all 0. So it's dot 0 dot, in this octet all 0 dot 0. And of course, /12. Let's erase here. So this would be our new subnet mask, and we know this is not a default subnet mask. 255.240.00. It's a side notation of 12. So having one class A IP address with a subnet mask of 255.240.0.0, it will give us 16 subnets, and inside every subnet we can have 1,048,574 available IP addresses. And here we can see the differences between host bits, network bits, and subnet bits. Remember, what are the subnet bits? The bits that we borrowed from host bits. They are considered subnet bits. In this case, these are considered the subnet bits because we borrowed from the host bits. And how many subnet bits? 4 subnet bits. 1, 2, 3, 4. And to find out the number of subnets, 2 to the power of subnet bits gives us number of subnets. 2 to the power of 4, 16. To find out number of hosts, 2 to the power of host bits minus 2, 2 to the power of 20 minus 2. Now if we had the side notation of 15, so I'm going to erase this one, So let's say with the side notation of 15, where will be the cut line? So we have to count 15 going from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So all this also turned on. So it's here. You see we move the cut line to the right. We will have less number of host bits now and more number of subnet bits. Therefore, it will give us less number of hosts and more number of subnets. Anytime when we move the cut line to the right, we will have less number of available IP addresses. We will have more number of subnets or subnetworks. When we move the cut line to the left, we will have more available of host bits, therefore gives us more available of IP addresses and less number of subnet bits, which gives us less number of subnets. So moving the cut line to the right, that's known as subnetting, breaking a large network into the smaller subnetworks. When we move the cut line to the left, that's known as supernetting, consolidating subnets into less subnets and each subnet having more IP addresses. So what would be the new subnet mask if we have the side notation of 15 and the cut line is here? So again, we have to convert this binary to decimal. The first octet, all 8 bits turned on, gives us 255. The second octet, all this turned on, only this one turned off. So in other words, we know when we have all the 8 bits turned on, that's 255, correct? In this case, we have only this one off. So 255 minus 1, that's 254. Or when we add all these numbers together, that's 254. Because again, this is the binary converting to decimal. And binary number of this gives us a decimal value of this. In previous videos, we talked about how we can convert binary to decimal. Please make sure to watch those videos. And now let's see how many subnets we will have and how many available IP addresses we will have per subnets. So how many subnet bits we have now? All this is a subnet bits, which is 1, 2, 3, 4, 5, 6, 7 subnet bits. So 2 to the power of subnet bits, which is 128. We will have 128 subnets. And now let's find out how many available IP addresses we can have per subnets. We talked about number of available IP addresses or number of hosts, 2 to the power of host bits minus 2, 1 for network address and 1 for broadcast address, right? So how many host bits do we have? All the zeros represent host bits. 8 here plus 8, that's 16, plus 1, 17. 2 to the power of 17 minus 2, which is 131,072 minus 2 is 131,070 available IP addresses per subnet. So originally, with the default subnet mask class A, big box with 17 million, that number we talked about previously, and now is a smaller subnets, basically 128 subnets, and each subnet we can have 131,070 available IP addresses. Now let's talk about class B subnetting, going over network bits, subnet bits, and host bits. So we talked about previously in class B, the range goes from 128 to 191, and the default subnet mask is 255.255.0.0 decimal format, and the prefix format would be 16 for the default subnet mask class B, which means it will give us 16 bits for the network bits and 16 bits for the host bits. So the first octet and the second octet, here as we can see, all the bits turned on. So let's turn on 16 bits for the network bits. This is a default subnet mask for class B. And we have 16 bits for the host bits, default subnet mask class B. And we talked about the number of hosts is pretty much 2 to the power of host bits minus 2, which is 2 to the power of 16. How many host bits do we have? Zeros represent host bits and ones represent network bits. So in this case we have 16 zeros for default subnet mask class B, 16 bits for hosts. So 2 to the power of 16 minus 2, which is 65,534. Now let's talk about subnet bits. Let's say they give us a side notation of 18. So we know this is not a default subnet mask. This 18 means 18 bits turned on, going from left to right. So here we have 8 plus 8, that's 16, 17, and 18. So let's borrow from the host bits. So all the original default network bits, considered network bits, so all this is a network bits. That's the default subnet mask for class B. We have 16 bits for network. In other words, 16 ones, right? And then we had 16 zeros based on the default subnet mask. Zeros represent host bits. So from host bits, in this example, we borrowed 2 bits. So these 2 bits known as subnet bits, and all the zeros known as host bits. So we know this is not a default subnet mask anymore. So it will give us a different value. And I'm going to erase this as well. And we will have different number. What do you think? More available IP addresses we will have, or less available IP addresses we will have? Very good. Anytime when we are subnetting, breaking a big network into the smaller subnetworks, we will have less available IP addresses. In other words, anytime when we are moving the cut line from left to right, we are doing subnetting. So we will borrow from the host bits. Therefore, we will have less number of host bits, and it will give us less available IP addresses. So this was our original default subnet mask with the side notation of 18. Now this is our new cut line. So all these bits, network bits, and all the zeros, host bits. And of course, these 2 of the network bits known as subnet bits, because we borrowed from the host bits. So let's see how many available IP addresses we can have with the 18, and how many number of subnets we can have. So the number of hosts, 2 to the power of host bits minus 2, because of a network address and a broadcast address, right? It's reserved, we cannot use them, so we have to do the minus 2. 2 to the power of how many host bits we have now? 8 bits here plus 6 bits here, which is 14, which is 16,384 minus 2, 16,382 available IP addresses per subnets. Originally it was one big subnet with 65,534 available IP addresses. Let's see how many subnets we have now. So number of subnets, 2 to the power of subnet bits. How many subnet bits we have? These 2 known as the subnet bits. Again, the bits that we borrow from the host bits known as the subnet bits. In this case, these two. All these ones, that's the original default subnet mask. These two we borrowed from the host bits. So we have two subnet bits. 2 to the power of 2 is 4. So we will have 4 subnet bits. And each subnet, we will have 16,382 available IP addresses per subnet. Now what is new subnet mask? Well, here, if we convert this binary to decimal, all the 8 bits turned on gives us 255. Here, all the 8 bits turned on gives us 255. Here, on a third octet, we have only 2 bits turned on. In this example, you know, the /18, so that's 18 ones, network bits. Therefore, in a third octet, only these 2 turned on. So if we convert the binary to decimal, 128 plus 64, because these 2 is only turned on, right? We just need to add the decimal values of the binary bits that it's on. 1 means on, 0 means off. So 128 plus 64 is 192. Dot, on the last octet, all the 8 bits turned off, so it's 0. Therefore, we know this is not a default subnet mask anymore. For class B, default subnet mask is 255.255.0.0. Having 255.255.192.0, it's not a default subnet mask for class B. This is known as classless subnet mask. And with this subnet mask, we will have 4 subnets, every subnet 16,382 available IP addresses. And if we want to write down this subnet mask in a shorter version, the Saddle notation format, /18. 18 bits turned on for the network. So again, as we talked about it earlier, if we move this cut line to the right, we will have less available of IP addresses because we will have less available of host bits. So that's subnetting. Moving cut line from left to right, breaking a large network into the smaller network to better manage the network or not to waste too many IP addresses, or for security reasons, we do subnetting. For example, let's say if they say /21. So I'm going to go ahead and erase, let's say 18. And of course, the number will change. And this will change as well. Okay, let's write down 21 here, /21. So what does it mean? We have to count 21 going from left to right, right? 8 plus 8, that's 16, 17, 18, 19, 20, 21. So we know we borrowed all this as well. Another example, I'm just using /21. So let's borrow more bits. So now our cut line is here. We borrowed from the host bits, so all this is subnet bits. So this was our original default subnet mask cut line, 255.255.0.0. We moved it to the right. We borrowed 1, 2, 3, 4, 5 bits from the host bits. This will give us 21 ones and 11 zeros. So number of hosts, 2 to the power of 11 minus 2, which is 2048 minus 2, 2046. So 2046 available IP addresses per subnet. Now how many subnets we have? We will have more subnets. So when we move the cut line to the right, we will have more subnets, but less available IP addresses per subnet. So how many subnet bits we have in this example? 1, 2, 3, 4, 5. So 2 to the power of 5, which is 32. We will have 32 subnets, each subnet 2046 available IP addresses. When we have a side notation of /21, and the new subnet mask is 255, here we see. Here on the second octet also 255, all the bits turned on. On a third octet we have only 5 bits turned on, which is 248. On the last octet all the bits turned off, it's 0. So we know this is also not a default subnet mask, because default subnet mask for class B is 255.255.0.0. But this one, 255.255.248.0, that's a classless subnet mask. And having class B network address with this subnet mask will give us 32 number of subnets, each subnet 2046 available IP addresses. Now let's go over class C subnetting. So we already know class C range is 192.2.223. So when we see IP address with the default subnet mask of 255.255.255.0. So when we see IP address of, let's say, 200.18.65.20, this is an example of class C IP address. How do we know? Looking at the first octet, 200 falls into this range between 192 to 223. So that's an example of class C IP address, and the default subnet mask is the first 3 octet belongs to the network and the last octet belongs to the host with the default subnet mask of 255.255.255.0. And if we want to write down the prefix /24, which means 24 bits is a network bits going from left to right. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is the default cut line, and here the rest it's 0, which is our host bits. 1s represents network bits, 0s represents host bits. So that's a default subnet mask for class C. And using the default subnet mask, class C, we already know the number of hosts, 2 to the power of host bits minus 2, because of the network address and the broadcast address. We cannot use them, right? That's why we do the minus 2. So how many host bits do we have? Zeros represents host bits. We have 8 zeros, 2 to the power of 8 minus 2. That's 256 minus 2, which is 254. So 254 available IP addresses we have. So this is one big network with 254 available IP addresses. But let's say we don't want to go with default subnet mask. So this /24. Let's say we want to go with /27. One example here. So is this /27, is this a default subnet mask? No. That's a classless interdomain routing. That's a classless subnet mask. So what does it mean? It means that we have 27 bits turned on for the network bits. So let's count. 8 plus 8, 16, plus 8, 24, 25, 26, 27. So this is our new cut line. We move the cut line from left to right. That's an example of subnetting. We will have more subnets and less available IP addresses per subnet. So all this turned on, and all the original network bits based on the default subnet mask known as network bits. And when we borrowed from the host bits, known as our subnet bits, and zeros means host bits. So this /27 will give us different value. Let's write down our 27 here. /27. So the subnet mask would be this 8, all the 8 bits turned on. So that's 255. So here we can see 255. Second octet, all the 8 bits turned on, 255. The third octet, all the 8 bits turned on, 255. On the last octet, we have only 1, 2, 3 bits turned on, which when we convert this binary to decimal, we just need to count and add the decimal values of the ones that's already being turned on. In this case, 128 turned on, 64 turned on, and 32 turned on. So 128 plus 64 plus 32, which is 224. So this is our new subnet mask based on this SADR notation. And we know this subnet mask, it's not the default subnet mask for class C, because default subnet mask class C, you guys already know, 255.255.255.0, not 255.255.255.224. So this 224 means 3 bits borrowed on the last octet. Here we can see 224. If we convert decimal to binary, we get this binary number. If we convert binary to decimal, we get this decimal number. So the SADA notation of 27, the subnet mask is 255.255.255.224. Now how many available of subnets we have? Well, the number of subnets, two to the power of subnet bits. How many subnet bits we have? So the bits that we borrowed from host bits, they are considered subnet bits. 1, 2, 3. 3 subnet bits, right? 2 to the power of 3, which is 8. How many available IP addresses we have per subnet? Well, let's find out. So how many, so we talked about this formula to find out the number of hosts. 2 to the power of host bits minus 2. 2 to the power of host bits. What's our host bits? Zeros represents host bits. 1, 2, 3, 4, 5. So 2 to the power of 5 minus 2, which is 32 minus 2, 30. So it gives us 30 available IP addresses, which you probably saw on previous videos. I talked about number of hosts. You can start with number 2 and going from right to left, 2, 4, 8, 16, 32 minus 2, 30, and we have to do the minus 2. That's the number of hosts. If you don't want to go by the formula, and the number of subnets for those subnet bits we borrowed from the host bits. So going from left to right for the number of subnets, starting with 2, 4, 8. That's also another way to find out number of subnets, 8, and number of hosts, 30, as we can see. So yeah, you can also do this going from left to right for the number of subnets, starting with 2 and double, or going from right to left, starting with 2 and double the number, and then making sure at the end doing the minus 2 till the cut line, where the cut line is the line between the zeros and ones, or by just using this formula. So if we see class C network address with the subnet mask of 255.255.255.224 or the SADA notation of 27, it will give us 8 subnets, each subnet 30 available IP addresses. This was an example of class C IPv4 subnetting, the differences between network bits, subnet bits, and host bits, which again, anytime when we borrow from the host bits, considered subnet bits. In this example, /27. which we borrowed 3 bits. And also, as previously we talked about, it's a table that we can learn and memorize. Anytime when we borrow 1 bit, it's 128. When we borrow 2 bits, it's 192. When we borrow 3 bits, 224. When we borrow 4 bits, it's 240. When we borrow 5 bits, it's 248. And when we borrow 6 bits, it's 252. When we borrow 7 bits, 254. When we borrow 8 bits, 255. So in this example, we borrowed 1, 2, 3, and the cut line is here, right? 27. So originally we had 24. That's the default subnet mask for class C. 25, 26, 27. So 3 bits borrowed, right? Which is 224. And here, as we can see, 224 on the last octet. We're working on the last octet. The cut line is on the last octet. So we just write down 224 on the last octet. Or in other words, when we convert this binary to decimal, that's 224. And these values, again, it's just coming from the decimal values to the top. How many bits turned on? We just add them. And it goes from left to right, the number of ones when we borrow. So to quickly recap, when we talk about subnetting, it's basically breaking a large network into smaller subnetworks. For example, when we have the IP address of 172.16.0.0 with the SADA notation 19, we know that this is class B IP address and this is not a default subnet mask. So how do we know this is class B? Looking at the first octet, 172 falls into class B network, and the default subnet mask for class B network, as we talked about previously, it is 255.255.0.0. So this /19 means we have 19 bits turned on. It's a network bit, which is not going to be 255.255.0.0. Let's find out. So 19 bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And the rest of them, it's 0. So for class B, default subnet mask is 255.255.0.0. It's basically the cut line is here. We have 8 bits turned on. Converting this binary to decimal, it's 255. It's basically adding all these decimal values because all the bits turned on. And this one the same. It will be 255 as well. And here we have only 128 turned on, 64 turned on, and 32 turned on. As we can see here, 1 represents turned on network bits, 0 represents host bits. So when we convert this binary here on a third octet, 111000000, converting to decimal is 224. So here 8 bits, that's 255. Dot here 8 bits, 255. Dot here only these 3 bits, that's 224. And here all the 8 bits turned off, so that's 0. So this /19 gives us 255.224.224.0. Therefore, the original default subnet mask, the cut line was here. It did move to the right. Now it's here. So let's erase this one. Okay, so when we talk about subnetting, here you can see that the cut line moved to the right. And we borrowed 1, 2, 3 bits from the host bits. These 3 bits that we borrowed from the host bits known as subnet bits. So here we have 1, 2, and 3 subnet bits. All the ones here represent network bits and zeros host bits, the ones that we borrowed from the host bit known as subnet bits. And we talked about if we want to find out the number of subnets, it's basically the formula 2 to the power of subnet bits. In this case, 1, 2, 3 subnet bits we have. 2 to the power of 3, which is 8. Also, we talked about if we go from left to right, starting at the bottom with number 2, 4, 8, that's another way to find out the number of subnets. And if we go from right to left, starting with 2, 4, and so on till here, and then -2, we will find out the number of hosts per subnets. So what was the formula for the number of hosts? 2 to the power of host bits minus 2. Why minus 2? Because one address is used for network address and one address is used for broadcast address. We cannot use it to assign to the computers on the network. It's mainly reserved for the network address and the broadcast address. That is why we have to do the -2 in order to get the total available IP addresses. So how many host bits we have? Zeros represents host bits, which in this case we have total of 13 zeros. So 8 plus 5, that's 13 zeros. So 2 to the power of 13 minus 2, which is 8192 minus 2 is 8190. So this IP address with the subnet mask of 255.255.224.0, we will have 8 subnets. Every subnet we will have 8190 available IP addresses per subnet. And as we talked about here, the number of available IP addresses, if we go from right to left, starting at the bottom, starting with number 2, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 81, 92. -2, 81, 90. That's total number of available IP addresses per subnet, and here we have total of 8 subnets. So these are also another way to find out the number of subnets and the number of available IP addresses per subnets. So now to calculate the subnets and be able to find out all the subnets, what we have to do. So after converting the subnet mask into the binary, which in this case they gave us the IP address and the CIDR notation. So we just had to draw 19 bits because this 19 is the number of network bits. So going from left to right, 19 ones, and then draw a cut line and the rest of them 0. Or if they gave us the subnet mask, we just need to convert the subnet mask into the binary. The first octet 255, when we convert it to the binary, all the 8 bits turned on. Second octet 255, when we convert it to binary, all the 8 bits turned on. The third octet 224. So the decimal value of 224, when we convert it to binary, it will give us 1110000. Again, in previous videos, we talked about how we can convert decimal to binary, how we can convert binary to decimal. Please make sure you watch those videos. And then on the last octet, we have 0. Decimal value of 0, when we convert it to binary, is 8 zeros. So after finding out our cut line, then we need to pay attention on an interesting octet. The octet that we have the combinations of ones and zeros, it's basically the last octet in the subnet mask that contains ones. In this case, in this subnet mask, the last octet that contains ones, it's this octet, which is the third octet. So this octet known as interesting octet. That's basically where we have the cut line. It's this one because we have 19. When we count 8 plus 8, 16, 17, 18, 19. That's the cut line, the rest of them 0. So the third octet, known as our interesting octet, that's the first step, to find the interesting octet. The second stage, we need to find out our network increment, or block size. How can we find out? Well, if I put it in the easy word, simply the last bit that is turned on, we have to look at the decimal value, in this case 32. That's our network increment or block size ID. Or on an interesting octet, when you convert the binary to decimal, in this case is 224. And we have to subtract it from 256. So 256 minus 224, which is 32. And the 32 is our network increment or block size ID. Or again, you can just take a look at the last bit that is turned on, in this case this one, and the decimal value 32. That's the network increment. Then we have to find out the zero network. How can we find out the zero network or the first subnet? It's basically we have to turn off all the borrowed bits. In this case, which ones are the borrowed bits or the subnet bits? These are the borrowed bits. So on a borrowed bits, we have to turn off and then just write down the IP address that in every octet we have all the bits turned on. So if we turn off these bits, we will have only the first octet and the second octet all turned on after turning off the borrowed bits. Therefore, looking at the IP address, the first octet we have to write it down, and the second octet we have to write it down. The rest of the octets we have to put 0. And actually in this case they already gave us the zero network. So let's rewrite it, 172.16.0.0. That's known as our first subnet. Or in other words, just basically look at the first octet in the IP address and see what class this is, and then apply the default subnet mask. So this is class B, 172 falls into class B, and the default subnet mask is the first octet and the second octet is the network bits, and the rest of the octets are host bits. So in class B, default subnet mask is 255.255.0.0, so we just need to write down the ones that is 255. In this case, 172 and 16, 00. 255.255.0.0 when we apply the default subnet mask. So anytime when you want to find out the zero network or the first subnet, you just need to apply the default subnet mask. And then for the host portion, just put 0. So quickly give you guys a couple of examples. Let's say if we have 10.18.9.32, and if you want to write down the 0 network or the first subnet, for example, of course 10, that's class A, so we know default subnet mask is 255.0.0.0. So the octet that it's 0, we just put 0, and the octet is 255, we write down the IP address. In this case, will be 10.0.0.0. So this will be our first subnet, or the network address. Another example, if we have 172.16.85.35, we know this is class B. Default subnet mask is 255.255.0.0. Therefore, the network address or the first subnet would be 172.16.0.0. So for the host portion, the IP address we just put 0. Or another example, if we have 192.168.5.28, we know this is class C. 192 falls into class C range, and the default subnet mask for class C is 255.255.255.0. So for the IP address in the host portion, we just put 0. So let's rewrite 192.168.5.0. This is the network address or the first subnet. So that was our third step when we want to calculate the subnetting. Again, what was the first step? To find out the interesting octet. The second step, to find out the increment, which we talked about, the interesting octet, the binary converted to decimal, and then subtracted from 256. Or the last bit turned on, what is the decimal value? That was the second step. And the third step, to find out the first subnet, which we just talked about how we can find out the first subnet. Okay, after finding the first subnet, we need to find out the next subnet, which we just apply the network increment on a working octet, or the interesting octet. So on step 4, to find out the next subnets, we just continue by incrementing using the block size ID. In this case, by 32 on a third octet, because the cut line is on a third octet. So the next subnet would be 172.16.32.0. Again, why 32 on a third octet? Because we are working on a third octet, and the last bit turned on, decimal value is 32. This is our network increment or block size ID. So the next subnet would be 172.16.64.0. Next subnet would be 172.16.96.0. And the next one, 172.16.128.0. Again, 96 plus 32. We are keep incrementing by 32 on a third octet. And so on, it continues. When do we stop? Basically, it will give us 8 subnets. How do we know? 1, 2, 3 subnet bits, correct? The borrowed bits are the subnet bits. We have 1, 2, 3. We talked about earlier, 2 to the power of subnet bits gives us how many subnets we can have. In this case, 1, 2, 3 subnet bits. 2 to the power of 3, that's 8. So we will have 8 subnets. And actually, if we continue incrementing by 32, you will see. To show you, let me erase all this. I'm going to write down here. And the next one would be 172.16.160.0. And the next one, if we continue incrementing by 32, 172.16.192.0. And the next one is 172.16.224.0. And actually, it's always good to know that always the last subnet is ending up with the actual subnet mask, where we have 224 here. So it will end up with 224. And if I show you 172.16.256.0, so we don't have 256, 224 plus 32, 256. We talked about in every octet, we have the range from 0 to 255. because of 8 bits, right? Every octet we have 8 bits. So the binary of 8 bits, all turned off, that's 0. Binary of 8 bits, all turned on, that's 255. The maximum value we can get 255. So if we continue incrementing by 32, we get 256. Therefore, this is our last subnet. So now if we count, this is subnet 1, subnet 2, subnet 3, or the third subnet, the fourth subnet, fifth subnet, 6, 7, and 8. This is our 8th, the last subnet. And as we talked about earlier, 2, 4, 8. This is another way to find out. Okay, now let's go ahead and take a look on a couple of the subnets and find out the broadcast address. For example, let's take a look first. Subnets, these are the available IP addresses. What would be the broadcast address? These addresses are our network address. So here, this column network addresses, or all the subnets, and here the broadcast addresses. So the broadcast address for the first subnet, always the broadcast address is one less than the next subnet. So for this subnet, the next subnet is this one less than this would be 172.16.31.255. If we add one IP address, this will be 256. We said we don't have 256, right? So it will be 0, and it will add to the third octet by 1, and it makes the 31 to 32. Here, as we can see, that's the next subnet. Okay, so after finding the first subnet, finding the broadcast address for the first subnet, all the available IP addresses in between, that's the range of all available IP addresses, which the first one is 172.16.0.1, and it goes to the last available IP address in this subnet is one less than broadcast address, 172.16.31.254. Now if we want to find out the range for the second subnet, so this is the second subnet, always it's better to find the broadcast address first. And how can we find the broadcast address? Broadcast address is one less than next subnet. So for this subnet, the second subnet, the next subnet would be this address. So one IP address less than this address would be 172.16.63.255. Now we have the network address and the broadcast address. In between, we can find all the available IP addresses, which goes from the first available IP address, 172.16.32.1, because 172.16.32.0, that's a network address, so the first available IP address would be 172.16.32.1. And it goes to the last available IP address, which is one less than the broadcast address, and it is 172.16.63.254. So earlier we talked about the formula to find out the number of hosts. 2 to the power of host bits minus 2, and here we can see the minus 2 IP addresses because of the network address and the broadcast address. These are the available IP addresses in between the network address and the broadcast address. So that's why we do the minus 2. And in this case, how many host bits do we have? 2 to the power of all the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Minus 2. As we talked about earlier, 8,190 available IP addresses. So here we will have 8,190 available IP addresses. Here we will have 8,190 available IP addresses. Same thing applies on this subnet. We will have 8,190 available IP addresses, and so on. So remember, this subnet mask 255.255.224.0 will give us 8 number of subnets, and every subnet we will have 8,190 available IP addresses. I can continue on the next one, next one, next one, and so on. It's exactly the same process. Just on the last one, when we have the 172.16.224.0, the broadcast one less than next, right? Next, address would be 172.17.0.0, right? So when we have, let's say this is subnet 8, the last subnet, therefore the broadcast would be 172.16.255.255. And this would be the broadcast address for this subnet. If we add one IP address, it will be 256. We don't have 256, right? So it will turn 0 and add 1 to this. And it will be 256 here, so it will be 0 and add to this. So that's where we see next network 172.17.0.0, which again, this will be completely other network. We will have total of 8 subnets. Subnet 1, Subnet 2, Subnet 3, 4, 5, 6, 7, and 8 here. If we keep continuing incrementing by block size 32, our network increment. So now if we go through the range, the first usable 172.16.224.1, and it goes to 172.16.255.254. And again, this range should be 8190 available IP addresses as well. As we talked about the formula, the number of hosts, 2 to the power of host bits minus 2. The number of subnets, 2 to the power of subnet bits. In this case, only 3 subnet bits, 2 to the power of 3, 8. 8 subnets, every subnet, 8190 available IP addresses. In the next videos, we will talk about supernetting, we will go over VLSM, and we will have more practice and exercises. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.